Welcome to the Computing Systems Lab at the Department of Informatics Engineering of the Faculty of Engineering of the University of Porto. We focus our work on the fields of computer systems, including advanced computer architectures, embedded and cyber-physical systems, and software notations and tools. Research and projects at our lab cover topics such as compilers and domain-specific languages, reconfigurable computing and non-conventional computing, performance engineering for high-performance computing, embedded and mobile computing, and distributed computing. Our success lies in our ability to gather senior and postdoc researchers with junior researchers and students in a creative atmosphere. Our mission is to perform applied and fundamental cutting-edge research to achieve consistent scientific advances, contribute to the education and training of human resources, establish cooperation with industry, and provide solutions for problems with societal impact. Here, one finds state-of-the-art tools and compiler techniques, FPGA and GPU-based heterogeneous computing, hardware that adapts on the fly, but mostly a constant look to the future of computing. And this is what defines us, a lab driven and inspired by custom computing and methods for accelerating changes, achievements, and innovation.
Okay. Good morning, everyone. So welcome to the second day of the Doctoral Symposium in Informatics Engineering 2021. Yesterday we had a very interesting day. So we had more than 9 hours of broadcasts of science. We covered a lot of subjects. I'm an engineer, so I like some numbers. We have 56 people registered to watch the conference, and we know this number because we have our registration software from Last to Ticket. That, by the way, is a startup that is based on UPTech, the incubator of the University of Porto. The sessions were very dynamic, so I have to thank everybody that was attending. We had registered 55 questions on Slido, a total of 55 questions. And I already checked this morning, and we have 344 views on YouTube. So, but if you didn't watch the last day, so yesterday's sessions, don't need to worry because everything is recorded, everything is available on YouTube with a good quality. And I think this record can also help future organizers, like we were helped, because 2 months ago we didn't know how to organize these conferences, this set kind of scientific conferences. So we could get some help from last year's organizers. So I want to thank you, Inês Teixeira, Sara Fernandes, and Liliana Antão, the chairs of last year's conference, and also 2 persons that teach us how to deal with the logistics and the relationship with the University of Porto, Sandra Reis and Pedro Silva. Thank you so much. Also, we were also inspired by another conference that took place before this one and was made by our colleagues from the masters, which is Talk a Bit. So we took some ideas. They were also pioneers in doing Talk a Bit completely online for the first time, and we learned from them. So thank you guys as well. So today it's going to be a very interesting day. I must say that the subjects seem all very sexy or popular. So we will repeat the most popular subjects from yesterday, which were machine learning and natural language processing. And then we'll have quantum computing. And we'll have our keynote speaker after lunch in one of the subjects that is a strong candidate to have a session in the next years of this same conference. After that, we will have the point of view of the companies. So we have presentations coming from the companies, and we will get to know what they are doing and what they are searching for. And then we will go to the more networking activities. We'll have a game that is promising, which is going to be a competition between teams like professor teams, PhD students team, a master's team, in a Q&A game that we hope will be also some fun. And then we will go and have the opportunity to spend some time networking and exchanging ideas. I should not forget that we are also brought to you because we have sponsors, and our sponsors are Primavera Software, LTP, Wakaru, DAB, CTEL, Ripley, and Natixis. So to start today, we have a session 8, which is the subject is machine learning, and our coordinator is José Rodrigues. So please, José, you have the word when you're ready.
Thank you, Tiago. Good morning, everyone, and welcome to the session in machine learning. I'm José Rodrigues, and I'll be the chair of this session. In this session, we will have 3 presentations, but before we start, I would like to remind our audience that you can place your questions through Slido with the code 482295, and you can also find the link in the description of the stream. So the first presentation will be done by Tiago Marques, and it's titled Association Rule Mining in Databases, Testing an SQL Approach to FP Growth. Tiago, when you are ready.
Thank you, José. I will share my screen in a minute. Okay, tell me when you can see it.
Yeah, we can see it.
Okay, nice. So, my paper is about association rule mining in databases, and I tested a SQL approach to FP growth. In terms of
sorry, Tiago, sorry.
Yes,
it's not on full screen.
I'm sorry.
We are not seeing the slides change.
Okay. I'll share the screen. Okay, so can you see it now?
Not in presentation mode for now. Still not in. Okay, we see the presenter's view.
Okay. Let me try again. I'm sorry for this a little trouble. I'm just not used to present.
Yeah, it's normal.
Okay, I'll try the other desktop. And I hope this time it will work. Okay, can you see now?
Yeah, we can see
Perfect.
the screen, yeah.
So, like I said before, and sorry again, my paper is about association rule mining in databases, and it is about testing an SQL approach to FP growth. In this presentation, I will talk a bit about my literature review and why I chose FP growth and why SQL. Then we will take a quick look at the data preparation, the data set description, and how I performed cleaning and modeling. And then we'll jump directly into the algorithm implementation in SQL and where it falls short, how we completed it, the results we get, and finally the conclusion and some future works that could follow this paper. In short, there are a few popular algorithms for association rule mining, namely a priori, ECLAT, and FP growth. FP growth is the more efficient of the three, and there was an SQL approach to FP growth that was proposed by Koen as part of his PhD thesis. I dived deeply into his work, and I could see that his approach is on a very high level. There are lots of missing bits. There's missing code for many steps of the algorithm. So my challenge was to see if the actual implementation can be implemented successfully. Let's talk a bit about what is FP growth. So it is an algorithm to allow frequent item set discovery without a candidate item set generation, and it is made in two steps. First, there's a need to build a data structure called FP3, and it uses two passes over a transaction data set. After getting the FP3, this tree is mined recursively to extract association rules. So my motivation, why FP growth in SQL? SQL is a very popular language and is used in all relational databases and OLTPs. So that's a great opportunity to leverage database performance, and it is also very easy to store and retrieve information. In terms of how we aimed to implement the FP growth in SQL, so as we saw before, we take the SQL approach by Koen and we test it against a large data set. And we try to limit this algorithm implementation to ANSI SQL, which is pure SQL, not having, for example, procedural language, such as, for example, PL/SQL in Oracle or Transact SQL in SQL Server. So we want it to be as pure as possible. And then the contributions would be to, let's say, create a library that would be made available to developers, and also to enlighten about the use of SQL for other tree-based algorithms. In terms of the data set, so it is the online retail data set from the UCI machine learning repository. It has more or less 500,000 rows with 8 different variables, and there were many issues that required data cleaning. So also we created a normalized model from this data set to ease the SQL implementation. So here we have some of the issues that were found during data cleaning, and the normalized model that we built based on the data set. Here we can also see the code. So on the left, we have SQL code where I use regular expressions to filter the data set. And then on the right side, you can see the three tables. One is transactions, where we have our elements by ID. Then we have customers and products. The idea is to generate association rules, but without the entire description, just using IDs. Then we can later retrieve the information using database joins. So it's fairly easy. The first step to build this is to generate a table T line. The T line table is a filtered transactions table that respects a minimum support. Let's say, for example, the count of items should be at least 2. For example, there are 2 transactions with item 1 that exist in the data set. So we include these transactions in T-line. Also, this algorithm expects the data in a raw format. There are 2 options to generate. You can either use this raw format or an horizontal or columnar format. We opted for the line, just because it is more close to what is commonly found in transaction databases. So here we can see the actual implementation of the T-line. So we create a common table expression on top, which is based on where we filter according to the minimum support count. And then we use this table and we create an item order according to the item count. This order is very important for the next step of the algorithm, which is the actual construction of the DFP table. The difference in this approach regarding the construction of the FP table is that we have an intermediary table, which is EFP, where all paths are combined recursively. And only after this EFP, we are able to compute the FP table, where we store then all the complete item paths and the store counts. Again, it is quite a simple implementation in SQL. We make use of analytic functions a lot. Here we can see the use of the lag function, and also where we use also the item count to ensure that the item count is greater or equal than 1. Then we hit the wall, which is conditional FP trees. Conditional FP trees are, let's say, once we get the FP tree according to the path, the root path, then we have to mine conditional FP trees according to the different paths that we get until we have no further association rules to mine. The problem with this is we don't know the number of tables we have to build beforehand, and also it is very difficult to materialize data and perform recursion in pure ANSI SQL. It requires extensions to the language. Koen, for example, recommends using object path extensions. For example, in Oracle SQL, you have connect by path, but it's very specific to the Oracle SQL implementation, and we wanted to do something more generic that could be applied to all databases. To explain in a bit more detail, on the left you can see a figure where we have to build first a conditional FP tree for prefix path ending in E. And once we get this, we still have another opportunity to build another conditional FP3, but for the E. So here we have two levels of recursion, and it's a very simple example. In practice, in a real-world data set like the one we had before, the amount of conditional FP3s that we need to build can be really overwhelming. So in order to complete our algorithm, we looked for a library, and we found a Python library which is quite simple, and it's called PY FPGrowth. As you can see on the right side, where the code is actually invoked, we import this library, and then we simply extract data from the FP3 that we previously built using SQL, and we transform it in the format that this library expects it. So here we can see some results. Results are not actually very important in this particular case, since we are mostly discussing the actual implementation in SQL and whether it can be done or not. If this approach could work, it would be meaningful and interesting to check the results and compare them between methods or between libraries. For example, if I use FPGrowth in RapidMiner, and to see if the results are coherent with SQL. Since here we are not able to implement the entire approach, I don't think it makes much sense to discuss whether some item on the data set makes sense to be associated with another. So in terms of the conclusion of this work, we tested the Shrekun approach, and we saw that we were able to build the FP3 table quite easily, but not the entire algorithm. We hit definitely a wall when trying to implement conditional FP3s. Also, there is common validation metrics missing that are commonly used in association rule mining, namely confidence, so support in percent and not in terms of item count and lift. Also, combining SQL with this library is complex and requires implementing a lot of code by hand compared to using software and libraries that simply expect some data set or data frame. Like I said, then complementing the two approaches is not practical. In terms of performance, I performed this algorithm on a single board computer, which is a very weak processing unit. It uses an ARM processor, and it was still able to compute results quite quickly. 10 seconds for the data model, which is not directly part of the FPGrowth algorithm, but it only took 1 second to build the entire FP3 table, which is quite acceptable. In terms of future works, maybe there could be some way to compute conditional FP3s using ANSI SQL that we don't see. If yes, then complete this work performing comparison with other methods. Also include filter metrics, like I said before, confidence, lift, support, and so on. And also create then a boilerplate that can be reused by database developers. Also, what we found here, doing this work, is that SQL, because of the use of analytic functions and comment table expressions, is quite a good fit for simple tree-based algorithms. Here are the references, and that's it. Thank you very much, and I'm open to questions.
Thank you, Tiago. While we wait for questions to arrive, I would like to ask Professor Augusto Souza if he has any comments.
Yeah, okay. Thank you very much. Good morning for everyone. Tiago, I enjoyed your presentation, good slides, good posture. Your English is more or less good. It's more or less fluent. You started with your table of contents, the agenda or schedule of your presentation, an introduction where you include the literature review, and after that you started speaking about the FP growth, the motivation to use the FP growth, contributions, potential contributions, if I understood well. And after that, you described the implementation, the 3 algorithms used, etc. Finally, you presented a table with some results, and I didn't see a real discussion of these results. The results are only one table, a simple table with some issues, but let me go from the beginning. The main part of your presentation, the main remark is perhaps the absence of a description of the problem. What do you want to solve? What is the problem that you want to solve actually? Okay, this is the main miss that I felt here in this presentation. The literature review was included in the introduction. Perhaps the introduction has, in my opinion, the introduction has other objectives. In the introduction, we speak about the context, the motivation, the problem. Okay, and after that we make a section for the state of the art, for the literature review or relative work, whatever. Okay, the importance of the literature review is to show that you are doing something that has some part that is new against what others have been doing until now. Okay, the rest is okay. I believe that the data set, the database that you used is very big. You mentioned very huge numbers of number of rules in that database. So it looks a good example to work with. Let me go for the slide number 16. Slide of results. Yeah, okay. One detail about presentation. The right column is very difficult to follow. Can you see this? Because you have big numbers, but with small values. Many digits, okay? And in engineering, we don't use too many digits. 3 digits at least and are enough. Okay, usually are enough, and actually in the most of the cases, 3 digits are enough in your results. By other hand, the results that are integer, that have no fractional part, have no zeros on the right of the point. Okay, no, you should use exactly the same number of decimal digits, okay, in all the results, so it comes easier to read. And don't use too many digits, okay? 3 digits usually are enough. I can understand that in some issue it's not enough, but it's a particular case. So you have this kind of result. I don't understand very well, but in terms of time, and later you in the conclusions you say the performance is acceptable. Why not having also an evaluation of the CPU time of this work? Okay, with some variations. This is fast, this is slower, this and this is a good point also to the evaluation of one problem like this, if I understood well. The results after this, you didn't make a real discussion of the results. And one thing is to show one table, to show numbers, and leave the numbers to the audience to understand them. No, the speaker should help the audience to interpret those numbers and to make he is responsible to make some discussion of this. You see, this number is too low. It should be more. It should be higher because this and this and this. In other work, they obtained better numbers than this, or our numbers are better than those that were obtained by that author, etc. etc. This is a discussion that should be included also here. Okay. Performance acceptable, as you mentioned in your conclusion, is also a value that what is acceptable in your opinion. I know that you have only your laptop computer to make all this work. That is a very hard work, but some comparison should be made. Okay.
Can I ask
thank you very much.
Can I ask you a question, Professor Augusto? In this particular case, so we have the objective of implementing the entire algorithm using SQL, and we weren't able to do so. In that case, does it still make sense to still discuss performance and so in very detail?
Why SQL? Why this solution? This is a discussion that could be made also at the beginning. And when you start making this discussion at the end, you can also make some comparison with others.
Okay.
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 Thank you very much.
Thank you, Professor. I'll see the questions from the audience, and we have a few. So Philippa asks, do you have an idea how the performance you got compares to related work?
To related work, okay. In terms of here the question is a bit vague. I don't know whether it is about the SQL implementation or other methods, but compared with other methods, actually the computing of the FP3 seems to be faster on the database. Also, we can make use of indexes, and it can be also even further optimized. On the other hand, if we were working with extremely large data sets, this approach doesn't scale. It means that we can't parallelize work, and I know there are some implementations, namely, for example, on PySpark and big data libraries that perform parallelization and take advantage of multiple processing units. Here, like I said, we leverage the advantage of working on the database, but since we weren't able to complete the entire algorithm, I can't really speak if it would compare well or not. Only the FP3 I can really talk about.
Okay. As a personal question, what do you think would be the main benefits for the online retail to use these methods? Performance in terms of space, speed?
Okay, the main advantage we see first is that not many companies have skilled workers in association rule mining at their disposal. But one thing that most companies have is database developers on one hand, and on the other hand, relational databases. So being able to use SQL directly on the dataset with minimal work was the main objective and motivation behind this. Also, talking about motivation, the other motivation was because this was a paper made in the context of the data mining class. It was to understand an association rule mining algorithm in detail. So making an implementation in SQL allowed me to really understand the internals of the algorithm.
Okay. Thank you. One last question, and let's try to be quick because we are running out of time. From Gonçalo, why did you choose the value of 0.7 for the minimum probability parameter of the FP growth? Slide
Okay,
16.
it's an interesting question. Actually, it's the value that comes by default with the library. The objective of using this library was merely to complete the algorithm and to reach results, as this paper is mostly about the implementation, like I said before, not discussing results. I know, and from what Professor Augusto said, it is a flaw that should be fixed in another revision of this work, but it wasn't the main focus of this paper.
Okay, thank you.
Thank you very much.
Thank you for your presentation, and then now we will have a next presentation by Diogo Seca, and it's titled A Review on Oracle Issues in Machine Learning. Diogo, are you ready?
Yes, thank you, José. Let me share my screen first. Okay, can you see it?
Yes, I can see it.
Okay, perfect. So, hello everybody, good morning. So I'm going to present this paper entitled A Review on Oracle Issues in Machine Learning. This deals with Oracle issues, which are problems with a definition of what's the optimal output of a machine learning system. In this case, we present a review of the Oracle issues found in machine learning, and we present the state-of-the-art solutions for dealing with these issues. This includes also lines of research such as differential testing, metamorphic testing, and test coverage. So very thoroughly, we're going to go through the context of and motivation behind this paper, some of the most common issues in machine learning, and some of the solutions that I was able to find in the literature. There aren't many systematic solutions, but these are the most significant. Okay, so first and foremost, the Oracle problem. So this is a topic that has gained significant attention in literature, specifically to machine learning. It's an old problem, but it's been gaining a lot of attention in machine learning. And there's a difference between traditional software and machine learning in terms of how it relates to this Oracle problem. Because in the traditional software, you can just write a unit test that checks out the output of a machine learning system. But for a machine learning system, that's not always the case. And the data is considered the Oracle, but it's not guaranteed to be a correct representation of the problem. There's sometimes some issues, for example, noise, ambiguity, etc. But even if the algorithm, even if the data was completely correct, the algorithm would still have to be able to learn the model, and being bug-free doesn't guarantee that it will be able to achieve the intended maximum performance. So the identification of test oracles remains challenging, specifically because you have to have someone who has domain-specific knowledge in order to create these tests. And otherwise, this could amount to serious problems over time. Okay, so the most common issues in machine learning can be divided into two groups. The first one is issues which are inherent to the data, and issues which are related to the usage of the data. On the first column, we have the noise in the data, which can appear in both the features and the targets. It can be conditional on the target. For example, it could be caused by an exogenous variable. If we know what that variable is, it's a good idea to go look for more data. But otherwise, if we don't know what this variable is, we can just treat it as noise, for example, and continue the modeling process. There's also the case of partially missing data, in the example of having, for example, missing values in one column sometimes, or not always, otherwise you'd exclude that column, obviously. There's also the case of ambiguous data, in which, for example, you could have, in an image classification problem, you could have a zebra with a stripe pattern, and you could have a tiger with the same stripe pattern. So these are ambiguous. This could be interpreted by, for example, a convolutional neural network as ambiguous labels. The patterns are very similar. Another problem is the representativeness of the samples. If you're trying to survey what's the popularity of an election candidate, you should be careful not to survey only Republicans or only people, only Democrats, and you should be careful. For example, if you use a phone call approach to survey these people, you should be careful that most people that use those types of phones are Republicans. So you should be careful. You should be careful of that. Also, there's the case of irrelevant raw data. There's not much to say about this. There are some algorithms that work very poorly, that scale very poorly with this, such as k-nearest neighbors. If you feed it a lot of data, a lot of relevant data, it uses the calculation of distances, and with too many dimensions, it scales very poorly. With regards to the usage of the data, first, let's start with the framing of the problem. So I can pick again in the same example of k-nearest neighbors. If you're trying to, for example, in a problem of time series, you're trying to identify the trend, it's a bad idea to use k-nearest neighbors. Otherwise, k-nearest neighbors is known to not be able to capture that trend signal. So you should be careful of that as well. Should be careful of what modeling process you use for that. Another case is using poor modeling assumptions. One example to illustrate this is the case of convolutional neural networks versus dense networks or fully connected networks. The convolutional neural networks have an advantage, which is they assume that the same pattern can appear anywhere in the image, right? I'm talking about the problem of image classification. So because that same pattern can occur anywhere in the image, using that assumption, it's much more efficient to navigate the search space of the parameters which are ideal for this problem. So that's an assumption that's very helpful in the training of the model. Another problem is misinterpretation of the data. It's sometimes common for researchers or for developers, for humans to eyeball correlations and patterns when looking, for example, a two-time series. It's one common problem. Also, the case of irrelevant features. I'm not going to talk about this. There are some approaches which improve this a lot, namely principal component analysis and most recently autoencoders. They seem to yield very good performances in this area. And finally, the case of multiple hypothesis testing. If you're going to test a large number of hyperparameters, if you're going to test a neural network with a large number of parameters, large number of hyperparameters, a lot of choices, then you should be careful not to find yourself in this problem. If you throw a coin several times, eventually it will cause the pattern you're expecting. Right. So if you replicate that experience multiple times with different variables, eventually you're going to land something which you're happy with, and it's just it could be just caused by randomness. There are some ways to improve this, namely by using Bayesian optimization techniques, such as the Optino framework on Python, or just simply go through some more conservative approaches, such as using the Bonferroni corrections. The Bonferroni correction when you're using statistical tests for statistical significance. Okay, so after this, there's some solutions which are more or less systematic to these problems. The first one relates to differential testing, and differential testing in this case can be applied to machine learning by, for example, implementing the same machine learning algorithm with different variations, or implementing this machine. You can also use different machine learning models to the same data and see how the differences between these models. Well, look at the differences between these models, because they're diverse. So where they diverge, they may tell us something. And that's exactly what Liam and Pachinella did. They learned different models using different distinct learning algorithms, and then they looked at the instances where the predictions didn't agree on. That means where the entropy was higher. And by doing this, this was an heuristic. By doing this, this allowed them to identify ambiguous labels, data that was hard to model, mainly due to observability issues. They were, for example, they were not really present on the image. They were not really noticeable in image because the zoom was not focused on that particular item in the image, for example. And the last case was finding independence issues in the data. For example, if you're looking whether to classify an image as an image from a car or an image from a car wheel, obviously a car is going to have at least two wheels on the picture. So this could be one thing that could cause the model to fail, and they did manage to find that out using the differential testing. One topic related to this is also metamorphic testing, which was proposed to complement cross-validation by Dsie and others. In the case of synthetic data, it's not really needed because you know what the oracle is beforehand. But in the case of real data, the oracle is often unknown. That is, the optimal prediction you should make is often unknown. And metamorphic relations help generate test cases for real data. So metamorphic relations are basically a change in the training data in some controlled way, and this is very similar to data augmentation. It encompasses data augmentation, also encompasses other things. So these are the metamorphic relations we found in the literature. There's not much literature on this, unfortunately, related to machine learning, that is, but these were the most significant ones. So the first step if you have a new data set is to identify the properties of that data set that relates to the inputs and the outputs of the algorithm for your target. So after you have these metamorphic relations, you can start using them through any of your machine learning pipelines and see if in the end these tests satisfy the metamorphic relations. For example, if you shift the target by a constant, it should have more or less the same input if you train it on that particular data. Okay, so related to actual tools that you can use in practice, there's this interesting method, metric, not method, which is a dataset coverage, which is basically on all of these metamorphic relations, how many of it does our machine learning pipeline pass? So if it passes all of them, it should have 100%. But it still has some issues, and it's difficult to quantify it. There's still some problems in this area. There's also some frameworks, which, for example, if you have a data set, a pipeline, and you specify you already have the metamorphic relations specified, you can feed it into the Amsterdam framework, and it will do all the remaining work for you. It's an automated way to do so. And finally, the final solution that I'm working on, which is specific to time series modeling, is to use these concepts to test and debug time series models, more specifically to the application of forecasting. And finally, one other group of solutions is simply to use robust modeling practices. So this is, GANs are known to do this, to use adversarial training to generate attacks to the model and force the model to learn from these attacks. Another approach is to use meta-learning. Not all meta-learning, just the the methodology that relates to using data from other domains to improve training. This includes transfer learning, few-shot learning, and zero-shot learning. And finally, the typical monitoring during the modeling to see how it fares, and monitoring after deployment. So we've reviewed the research paths that try to solve or at least minimize the impact of some of these Oracle issues. And we also anticipate the creation of novel techniques, most related to the field of meta learning. Next steps for this work is to build a taxonomy on the issues and metamorphic relations, and to improve the systematic literature review. Also, I'd like to thank the reviewers. They've made some very, very good, interesting comments. I couldn't implement all of them, but I want to implement them in the near future. So thank you very much for the time. And these are the references. And now I'm available to questions.
Thank you, Diogo. While we wait for more questions from the audience, I'll ask again if Professor Augusto has some comments.
Okay, Diogo, very good presentation about one work that is starting. You are reading, you are taking information about many things. It's like a survey. Yeah, as a survey is good. The only thing that I think it should be improved is at the end, make a summary of all the stuff that you discussed and conclude that in these conditions, this is better, in that conditions, in those conditions, that one is better, etc., etc. You know, so this is a good help for the readers, for the audience facing your presentation, but it is also a good help for yourself when you later on in 1 year or more than 1 year, when you go back to your studies and try to evaluate your above decisions or try to write something new or something. Okay, so you started with the contents, making a definition of your problem. You have been speaking also about the common issues on in machine learning, and this was a slide number 3, and you were a long time in this slide. Okay.
Yeah, that's true.
Let me tell you one thing about this slide. I'm not saying the slide is incorrect or it is bad. No, it's good. And each problem that you mention here, issues in the data or poor usage of the data, each problem here it's like a problem. It's like a research question. Okay, it's not, but it is like. You can ask, what is the solution for the problem of the noise in the data? What is the solution for the ambiguous data? What is the proper algorithm to solve this?
That Professor Augusto lost connection.
Yeah, stop hearing.
Okay.
Can be more solved with this algorithm. This problem can be more solved with this strategy. This, okay. So
Professor,
showing to the audience.
Professor Augusto, we lost you for a while, so I don't know what you said for the past 10 seconds, I think.
Oh, I can repeat. This table is like a list of research questions. It can be interpreted like a list of research questions, okay? So at the end, it would be nice if you gave the audience your interpretation about the solutions that you presented facing these research questions. Saying this research question, this problem, saying this problem can be solved by this algorithm. This problem can be solved by that methodology, or these methodologies in a set can be used to solve that problem, etc. Okay. And we have here different things. One thing is the problems in the data themselves, and The other thing is the problems that are coming with the user. Okay, usage of the data is responsibility of the user and not the data. But what we are saying is, how can we help to make the system independent of more independent of the user errors? But it was a good presentation,
Thank you.
presentation, like a survey, like several methods. You mentioned that you are working especially in time gene solution. Is this true?
Yes. I'm working on this. This is going to be a Python package for testing machine learning pipelines to forecasting, applied to forecasting.
Okay. So this will be the next paper. This
most likely. This is the one I'm working more closely on.
Okay, I'm waiting for it. Okay.
Okay.
Thank you very much. Good presentation.
Thank you. Thank you.
Thank you, Professor. We have a question from the audience. Gonçalves asks, in slide 3, what is the difference between irrelevant raw data and irrelevant features?
Okay, so irrelevant data. So if you, in a typical machine learning problem, you're given raw data. Let's say you're giving 3 columns. You can calculate an infinite amount of features based on those 3 columns. That's irrelevant features. You're going to get irrelevant features if you do that. But if instead of only having been given 3 columns, 3 variables in your data set, imagine that you're given 2,000 variables, which is a common case in NLP. But NLP is more complicated. I don't want to go there. But let's say in a typical problem of regression, you're given like 2,000 features to predict the next value of a time series. Those 2,000 features are probably too much, and some of them are likely to be irrelevant. So that's what I mean by relevant raw data. I had to find a way to distinguish them both, so that's the way I found. Perhaps it's not clear, so I'll make a note to clarify this.
Thank you.
Thank you, Dennis.
Next question from Fahid is in slide 7. Did you extract all the completions on the right side from the references that you mentioned?
I did what? Could you?
Did you extract all the conditions on the right side from the references that you mentioned?
Yes. Some of them were repeated. Others were specific to these papers. So this is actually one of the things I want to improve in a systematic literature review, is to attribute these things, which was one of the comments by the reviewers, which is to attribute these issues to the authors of these papers. On which of these issues do they agree on? On which of those issues do they don't agree on? Because there's some discussion in this area, but it's a novel area. It's a new area. There's not many things.
And one last question from Soraya. Were you able to test the solutions found on real data?
No, I was not.
Okay. Thank you for your presentation, Diogo.
Thank you.
Now we will have the next presentation that it's done by Pedro Moreira, and it's entitled Supervised Machine Learning Approach to Aspect Category Detection. Pedro Moreira, are you ready?
Yes, I'm ready.
Okay.
I'm going to share the.
You are having
the yes, I know.
No, but it seems like you are
good.
Let me say just a thing. It seems like you are having a low internet connection. Maybe if you turn off your camera, it will allow.
If I what?
Turn off your camera.
If I what to do? Yes.
Pedro Moreira,
Sim, sim.
não é nos slides, é... Tenta desligar a tua câmera no Zoom, em baixo.
Exato.
Basta clicares em cima da câmera, no Zoom.
Não estou a ver aqui a câmera. Aqui. Talvez assim.
Não, continuas a aparecer.
É porque está em partida de ecrã. Tem que ser em cima, no monitor, se calhar.
Interrompi.
Sim.
Agora, com o botão direito em cima da tua fotografia.
Aqui. Exato. Ou então aqui interromper o vídeo, não? Assim.
Isso.
Sim.
Pronto, ok. Vou tentar.
Nem mais.
Muito bem. Agora, já estão a ver?
Sim.
Pronto. Ora, muito bem.
Sim. Okay, you can start.
Okay. Can I start? My work is about supervised machine learning approach. It's the title of the work. And agenda
Pedro.
Yes.
Só um bocadinho. Podes tentar afastar o microfone da boca ou qualquer coisa, está a ouvir muito ruído.
Muito ruído.
Não se consegue perceber praticamente nada.
Isso é problema de microfone, isto não é problema de rede.
Ok.
Será o microfone. E agora, estão a ouvir bem?
Sim.
Estou a fazer uma bem melhor? Melhor?
Sim.
Melhor?
Sim.
Muito bem.
Força.
Ok. The agenda of this work, it was, I'm going to do a little introduction that traits about the natural problem and purpose and significance of the research, the hypotheses or objectives of the study, the method by which the problem is approached, the related work, the materials, procedures and methodology. We speak about the data set, the proposed model, the procedures and main steps, the results and another section with the results of and discussion, the results of the spectrum category classifying through the confusion matrix, evaluation matrix, and we are going to trade about the distribution, another study about the distribution of attributes by aspects categories in testing data set, in the original reviews data set, and word clouds in the original data set about two aspect categories. Then the conclusions and future work. The introduction, you have a naturalism problem. The internet has become the means of expressing opinions and viewed consumers' products and service. The sentiment analysis focus on one opinion of the entire text of consumer reviews, but the consumers talk about multiple aspects. Aspect-based sentiment analysis emerges just to detect the opinions expressed on different aspects of a given entity. Also, hypotheses of this work are perform the extraction of aspects, more precisely aspect categories, detection or extraction is the same, identify attributes of an entity, the entity AE and entity A pairs in a given sentence, and validate another hypothesis, it's validate the classification, the different algorithms that were used in this detection or extraction of the different categories. The method which the problem is approached. Basically, it's one where data set that was collected for it's called for the square gold, and conduct experiments through a proposed model and its main functions. For aspect categories classifying were used the knife base, support vector machine, decision tree, and random forest. A related work. There are several approaches of previous studies about to perform the ABSA, like that includes the most of the processes were machine learning centric. Many supervised classifiers have been used for aspect extraction in the literature. It has been observed that machine learning's approach have excelled in aspect extraction tasks. And it is also observed that most of the best performing supervised machine learning models use SVM. In contrast with this approach through the supervised machine learning, deep learning supervised methods are also used. And Tom et al. Presented an hybrid approach which uses deep learning techniques along with the binary classifier. They obtained in Ceneval 2016 task 5, in the restaurant domain, they achieved the best score in this task, of course. Now we pass to the materials, procedures, and methodology of this work. The dataset. The dataset is called Foursquare Gold. It is a dataset with a sample annotated with aspect-based sentiment annotations from English Foursquare restaurant reviews, with 585 reviews, 1,006 sentences, and 1,115 2016 XML format with triple OTA, semantic aspects, and polarity. This is typical. The entity refers to entity of the pair of entity attribute pair. Attributes are aspect categories of one determined entity, and attribute pair, you attribute A of the pair entity attribute towards which an opinion is expressed, and the polarity of the aspect category. This dataset was restrictions that are shown by the table on the below right. You can see on the left column the entities of this data set and the possible attributes that were assigned to the entity. The model, the proposed model that treats this work, you have here a scheme. We collect data set in XML, remove XML text, data set reviews to put the data set in formats CSV, and then we did the data pre-processing, then with the cleaned data, the feature, a task will be done. It was the feature extraction, split the data set, used these four algorithms, classifiers algorithms, and the predictance aspect category. I'm going to treat about the procedures, the main steps. It was the first step to remove the XML tags, remove the XML tags of the dataset, convert to CSV format, but with attention to dropping the sentence with for which the corresponding opinions categories are not provided. Sentences with multi-aspect categories assigned with corresponding polarity. Here you can view this scheme. In the left, the data in format XML. In the right, the format in CSV. This data, the data set, the original data set, we saw that it contained 1,150 tuples or opinions with 6 columns. As you can see, the legend of the columns, and then the next step, it was to do the data processing, removing unnecessary characters, filter stop words, lemmatization, parts of speech tag. Then another step, it was the feature extraction to identify every entity and attribute A of pair towards which an opinion is expressed. For category extraction, the category value of the tuple is used as label of the feature vector. As you can see on the column at the gray column, you can see that the category cat as when it's the same, they presents the same value of category cat, and this is the feature that is used to classifying in the next step. We apply the TF-ID vectorization for training the statistical algorithms using machine learning, and then we split the data set was splitted into 2 data sets, one for training, another for testing, and was faults, and the data set stayed with 773 tuples. The testing was stayed with 382 tuples. Basically, it was this step of split the data set. 1/3 of the data set original data set was to testing data set, the 2/3 to training data set. The next step was to aspect category classifying. These assess whether the system correctly identifies the suspect categories towards which an opinion is expressed in the text. The supervised machine learnings that I referred ago, and used with 10-3. The experiment results were given through confusion matrices, and to evaluate the results were used this evaluation matrix. As you can see, the accuracy, recall, precision, and F1 score. Now you can see the results. Another section, it is the results and discussion. The results were given by these 4 graphical matrices, confusion matrices with the results, and we can immediately see that the best accuracy, as you can see through my cursor, that the best accuracy is in general was given by support vector machine accuracy with accuracy 0.52, followed by NB both with 0.47 value, and the worst performing classifier it was the decision tree with 0.42. To evaluate the experimental results were used the evaluation metrics that I spoke ago, and the global values or the classifiers. We are focused on overall performance of or better through the global values. The global values given by the confusion matrix, and these result that to best that in overall performance, the SVM and RE and the random forest were the two best, both with F1 score equal 0.46. But the SVM seems to overlap the random forest due higher accuracy value and with the metrics precision and recall are also high. Then you can see you see it was after the SVM and the random forest is one that overall presents the best classification results, overlapping the performance of the naive Bayes. It was the decision tree. The naive Bayes, it was the worst classifier. Now we are evaluating the experimental results in focus in which one of the aspect categories, not in global values, but in which one of the aspect categories. And we can see the table given by the program, and you can see that the N-Bayes classifier, it was the one that best classifies the aspect category food quality. You can see through the legend, the F hash key, it corresponds of food quality with a recall of 0.99. With 171 true positives over 173 true positives plus false positive. These values can be tested by the results of the confusion matrix before. The SVM classifier also has a high value for his aspect category, food quality, and the one that best classifies the aspect category is the aspect category, the service general, with a recall with a recall 0.53. The decision tree and random forest classify the largest number of the class. As you can see, through the colors of the table that the table presents a gradation of the color with the blue dark. It was the aspect categories or class that was better classified, and then successively with the color less dark, more white, you can see the class that were starting of the dark color to the gray color. You can see the gray color represents the aspect categories that weren't classified. Then another study that it was made, it was the distribution of the attributes by the aspect categories in testing data set. And we concluded that the testing data set was very, very unbalanced, as you can see in green and another colors. And the spec categories are those that have the highest number of occurrence. You can see this table with the number, the table of the left, the white table, you can see the number of occurrence, and you can see that through the table of the right, that the aspect categories that are the blue colors are those that presents more number of occurrence or attributes. This also means that the dataset distribution in the testing dataset is unbalanced, but the training dataset is also unbalanced because the dataset was split in a way stratified. It's the same. The testing dataset is unbalanced, the training dataset also, and the original dataset, because they were all stratified. Another study is a distribution of attributes by the original attributes, and you can see by the aspect categories in the original reviews dataset. And now you can see through the chart that we have on the chart on the left circular chart, we have the aspect categories, and you can see that 3 categories: food quality, service general, and restaurant general, represent 71% of all the data. And 9 categories only represents 29% of the data. As it was the data set that data set about the restaurant domain, you can see that the aspects, the right circular chart represent the aspects, and the aspects more commented, it was the aspect food with 52% of the opinions. You can see that this aspect, it's not, now you are speaking about the entity, not the attributes. When you speak about the attributes, you are referring in special aspect categories. In this case of the right circular chart, we can speak about the entity. It's less refined. Now you can see the distribution of attributes by aspect categories in the original dataset, and these give us a number of occurrences or opinions, and I choose 2 aspect categories, but I could choose another. And I put the 2 aspect categories like restaurant general and food quality. You can see these 2 examples. Finally, the conclusions. You can see that this work performs one of the answer at one of the hypotheses. It was and performs the aspect categories detection and extraction, but the performance measures another hypothesis was the validation of the classification, and it was you can see that the overall performance involving all the class, the best performance were the SVM, RE, random forest, followed by decision tree, and the worst performing, it was the naive base. For the performance for individual classes is the way it is the detailed for individual class, the better results. It was a multi-class classification. The better results were similar were presented by the decision tree and random forest. They classified bigger number of classes, not accusing so much the imbalance of the data set. The limitations of this work, it was that there is no comparisons with other works they analyze that could analyze this data set, and another limitation it was that only one data set was used, and it was too small. Both the training and the testing data sets and the class were highly unbalanced. And when it is this way, analyzing algorithm performance on class for which there are a few samples is practically unsuitable for machine learning. It was one limitation, but it was the data set that I received when I started to do this work. For future work, the recommendations for further work, it is comparison with previous work should be added, using larger data sets with a greater balance of its class to improve the accuracy of the results, to experiment other classifiers, and maybe the data processing will maybe reviewed. To do and another tasks to continue to develop the other ABACA analysis, ABACA tasks and analysis, like, for example, extract linguistic expressions to refer an entity of the pair entity attribute pair, and to detect the correct sentiment label that this work didn't trade, but it was for future work. And that's all. Thank you very much for your attention. Thank you.
Thank you, Pedro Moreira. I'll ask Professor Augusto if he has any comments.
Pedro,
yes.
Are you listening well? I have to start here. You had 15 minutes to make your presentation. Do you know how much time have you spent? Half an hour. Sorry? Half an hour, the double of the time.
Double of the time.
The net is not good again. We are not listening you.
It's not too
good. Okay. This is the main problem.
Because
Pedro.
the work is bigger, is big. The work and to put any things, all the things on the slides is difficult.
You have to be used to synthesize what you have to explain.
Yes.
You entered in too much details in several parts of your presentation.
Yes.
And you have to synthesize.
Of course.
Using black boxes. This is a black box. This is the entry. This is the output. Without explaining. And some boxes are not black. Some boxes you explain better. That are those boxes where you invested your work. Okay. So this is my main remark. You have to train yourself to make a synthesis of the work. It looks, this presentation looks like a copy paste of the text of your paper, and can't be. Okay. And okay, this is one remark. After that, you started with your agenda. Immediately in the agenda, we understood that the presentation would be too long, because also the agenda was very long. To present an agenda, I would only present the main titles here in this slide. I would not go for the second level of these titles, okay? Only the first level. Introduction, related work, material, etc. And perhaps determining one or two words, speaking, not writing or something, okay? That it is the granularity of this slide is too fine to be honest.
Excuse me, can you repeat, please?
Do you want me to speak in Portuguese?
Oh, I understand in English.
You understand? Okay. I was saying that the nature of the information in this slide is too fine. The granularity is too fine. Okay. Very
Yes,
small details.
Yes, than the introduction, no?
No. I was speaking about the agenda.
The agenda.
Yeah.
Yes.
In the introduction, you define it the problem. Perfect. Again, with too much detail. Much detail is common in every slide, and because you wanted to put too much information in one slide, the font became very small. Also, in a practical presentation in a big room, it would be difficult for persons far from the screen to read this text. The text is too small. Okay, the font is too small because you wanted to put too much information in the same slide.
Yes, but if there is a problem, if the font is bigger, the slides rests.
That's why I'm saying
too full.
you wanted to put too much information in each slide.
Yes, of course.
Because also you were reading some slides, okay? The initial slides, you were reading the text that was written in the slide.
Yes.
That's one or two variation, and this is not very elegant also. It's better to have a simple slide with keywords, and on your side, in paper or in another screen, you have the text that you are reading, okay? It's better,
yes.
Okay? Reading the text that
well.
is being presented is not nice, okay? Not elegant. After that, you entered to the related work. I have no comments about this. And after that, you decided to present materials, procedures, and methodologies. So what you have been doing. And this is the main part of the work and too extensive. I don't remember. Can you put slide number 12? I don't remember. I have here a mark, but I don't remember what it was.
12. It's 12.
It's results. Next one.
Results, but it's a result.
This one.
12 results.
Because we don't understand what each graphic is.
Yes.
Can you summarize what each graphic is? What are variables? What represent colors?
This is a chart that with the confusion matrix of the each one of the corresponds of one algorithm classifier, and on the rows you can see the aspects categories, and in the values on vertical are the prediction that the classifier algorithm do to the aspect categories on the rows.
Okay.
Yes, the values are, as there are 12 classes, 12 aspect categories. Of course, it's no way to put these in form more perceptible. It's no way, because there are many classes. 12 is difficult to put the form matrix, confusion matrix.
Okay. Another thing with this graphic is the use of colors. This use of colors have some problems. Namely, if projected in a screen, I adopt that some squares that are painted with a little darker color would be visible. Okay.
Yes.
The projector, usually a projector makes a very bad image, and this difference of colors are very difficult to be projected sometimes.
Yes.
So if you can have another way to present this, it would be better. Even using colors instead of levels of the same color, okay?
Yes.
And okay, we have to stop here, Pedro. You have to practice a little more on presentations. Your English mainly, obviously, you know that your English needs to be improved. My advice usually is try to speak to your colleagues in English. Try to use English more times in your lab, in your presentation, in your private presentations, etc. So you can improve it because there are some problems here that you have to solve for your future. Okay.
Of course. Thank you very much.
Thank you
for you.
Thank you.
Thank you,
Professor. We have some questions, but we are well over time. I think it's better for the authors of the questions to contact directly the author of the paper. So I think we end this session here. Tiago.
José, thank you very much. Thank you for the work with animating this session. I think you deserve the usual applause, isn't it, Professor Augusto? So, yeah. Okay, so we are behind schedule. So we had planned to have a break of 30 minutes, actually. So what you're going to do, as usual, we will be exhibiting next a video about the activities of the research labs that surround the Faculty of Engineering and the University of Porto. So we will learn more about the excellence of research that is being made here. And then we will go into a break and maybe to have something to eat. So let's schedule and come back by 11:30. So it's 20 minutes. So we will be back at 11:30. So I'll see you guys there.
Okay.
Thank you.
Today, researchers try to solve real problems through real science. Here, we do the same. We just take it with a pinch of humor and a creative mindset. Welcome to GIG, the Computer Graphics, Interaction and Games Lab at the Faculty of Engineering of the University of Porto. GIG is a place where science meets imagination and innovation is an attitude. Our mission is to research, explore and develop the fields of computer graphics, interaction and game design and development through the continuous evolution of the connection between people and systems. And we do so in a highly transparent, efficient, natural and pleasant manner. GIG is all about its people and what they can achieve together. We gather senior and postdoc researchers with PhD and master students and other junior researchers in a collaborative atmosphere that leads to top-notch research projects. Research at GIG in computer graphics revolves around 3D modeling and animation, realistic and real-time rendering, as well as procedural modeling of 2D and 3D environments. These core topics are explored at higher levels in contexts such as multi-sensory virtual and augmented reality or games. In the field of human-computer interaction, we focus on user interaction and user experience, applied not only to regular computer applications, but in particular to immersive or mobile environments. We combine technology and design principles to research and develop multimodal, natural user interfaces and study their usability. graphics and interaction come to play together with other topics in the multidisciplinary field of game design and development. Here, we work not only in the processes of game creation, design, and development, but have a particular focus on serious games, location-based games, and gamification. At GIG, we believe that excellence in these main fields of research is only achievable through creative collaboration. To uphold this multidisciplinary approach, we work together with other key players at our faculty, such as the Sound and Music Computing Research and Development Lab or the Computer Graphics and Multimedia Students Group. We go beyond the Faculty of Engineering, having frequent collaborations with research groups at the faculties of Fine Arts, Psychology, Sciences, Liberal Arts, and Economics. This is what defines us, a passion for enabling engaging experiences through multidisciplinary research, from people to people. While Hollywood movies and science fiction novels depict artificial intelligence as human-like robots that take over the world, the current evolution of artificial intelligence technologies isn't that scary. From its beginnings in the 1950s, with neural networks steering excitement for thinking machines, through the rise of machine learning in the 80s, to today's boom with deep learning, artificial intelligence had, has, and will have a profound impact in our lives. Welcome to the Artificial Intelligence Lab at the Faculty of Engineering of the University of Porto. We are devoted to contributing to the theory and application of artificial intelligence, carrying out research and development activities spanning all dimensions of intelligent systems. Research and projects at our lab cover a wide range of topics, such as data analysis and engineering, multi-agent systems, natural language processing, intelligent robotics, intelligent transportation systems, and parallel and distributed computing. Our device solutions benefit from approaches built upon distributed and decentralized coordination and cooperation mechanisms to improve performance in rather dynamic and uncertain environments, as well as robust machine learning and data science algorithms with a vast range of applications to real-world domains. This is what drives us. A commitment to ensuring the ethical, transparent, and accountable use of artificial intelligence to impact society.
Good morning, everyone. My name is Gonçalves, and as chair of the Natural Language Processing track, I'll be moderating this session. This is the second of two sessions dedicated to NLP. The first session took place yesterday afternoon. In this session, we have three very interesting papers lined up to share with you. Our first paper, just like yesterday, we started yesterday with argumentation mining, and today we're going to do the same thing. We're going to start with argumentation mining with a paper presented by Tiago Costa Mendes. Tiago, the floor is yours.
Thank you, Gonçalo. So, good morning. Let me share my screen. Okay, so can you guys see my screen?
Yes.
Okay, so let me start here the timer. So All right, so my work, or the work I'm presenting here at the Doctoral Symposium in Informatics Engineering, is about classifying types of propositions in argument components. This is a task in the context of argument mining. So the agenda of my presentation is typical. So I'll talk about a little bit about the introduction, then the methods, techniques, and procedures, the results, and then the conclusions of this work. So motivations to study argumentation. First of all, what is argumentation? So argumentation is a process that's human, of defending points of view or opinions about a certain matter. So humans use it frequently to communicate and defend their positions or opinions, also to understand problems and to perform scientific reasoning. And why should we study this? This is important to build tools to automatically to find problems with plagiarism, and analyze authorship of documents, to analyze court decisions bias, detection of fake news, also identification of radicalization patterns when somebody is communicating in a certain way that can lead to a development of radical behaviors in society. Also improvement of recommender systems when we understand why people like a certain product. And another one, which is very interesting one, is also to understand the automatic decision-making mechanisms by humans, right? Because humans tend to not believe in decisions taken automatically when they don't know how they were taken. So the typical area of research is argument mining. Argument mining tries to extract arguments from natural language text and describe the internal structure of each individual argument. So we can see on the right side, there's a schematic of an argument, which is if all men are mortal and Socrates is a man, so then Socrates is mortal. This task can be divided in subtasks. So the first is text segmentation. So it's to take out the part of the text that is an argument. Then it's identification of the components, and the components you can see on the right side are the rectangles. Then we can classify those components and say if they are premises or conclusions. So the premises will lead to a conclusion. Then we can characterize the relation between these components, if they support or attack. So if the premises support or attack the conclusion. This is a work about component classification. You've got there one example of a component classification, which is the ADU type classification. But this has a specific characteristic which is relevant. That classification as a premise or conclusion depends on the relationship between the components. So you have premises because you have a conclusion that is related, and you have a conclusion because you have premises that are related to that conclusion. But there are other types of classification of components, and that's the one we are trying to approach in this work. So on the other hand, argument component intrinsic properties, which are independent from relationships in argument structure, also provide valuable information, namely about the component role. So if we take a component and we know that it's a verifiable claim, that means that we should be able to find a piece of evidence to support that claim. Or if the component is increasing the author's ethos, like somebody is saying that a certain speaker had a very good discourse, that means also that somehow this person is supporting the claim that that speaker made. And also it can tell us good information about the quality of the argument. So we can identify which premises, which propositions need additional reasons or evidence to be stronger and in a practical example, for example, to improve expressions of feedback. So when we want to express something that we want people to think it's true, we look for an evidence to support that. So in this classification, we use a typology proposed in this article made by Wagemans, which is the periodic table of arguments. This is a framework that comprehends a diverse set of schemas that existed before to characterize arguments. And it was quite confusing until this point, and this tries to comprehend them. So it became a reference in the area of understanding arguments. So and our types are three types. So we will have propositions of policies, which when this component invokes a need to follow an orientation or line of action, mentioning agents or entities with decision power, and in the context of polemic or public interest matters. An example is leaders should recognize their limits and acquire the missing knowledge. Others are propositions of value or opinion that can be of aesthetic, political, ethical nature. They are not verifiable, and they have a polarity, so they can be positive, like in the American president is an expert in the way he decides what the political and mediatic agenda should be. It can be negative, women continue to be regarded as inferior athletes, or it could be neutral. Trump is not an amateur politician that communicates unthoughtfully. And finally, the final type is fact. So the information is presented as being truth and may be verifiable. This often involves numbers. So one example would be this thrown away plastic could worth 105,000 million euros for the economy. So in terms of related works and argument mining, there is no relevant work for the Portuguese language before 2016. And after that, we have two projects involving Faculty of Engineering of the University of Porto. So we have ArgMine, and then after 2018, we have the ArgMeans. They are kind of a follow-up. The second is a follow-up of the first. But what matters here is that the data set that we're using in this project is a result of the ArgMeans project, and the annotations it made possible with their platform. So in terms of the state of the art, as far as we could access, there is no previous work to predict types of preposition of policy value, in fact, in Portuguese. For the English language, there are several works that can be referenced, namely in the area of fast checking, that is related with two of our three class types, fact and value, like, for example, in political debates and Twitter opinions, opinion posts, yes. We have Adam and Bashir, for example, identified evidences as either news media accounts, so they try to support opinions based on news or based on blogs, or they didn't even present any evidence. And those Mano classified argumentative tweets as either fact or opinion. But more closely to our case, we have the work of Park and Cardy that examined online user comments for propositions which could be unverifiable, verifiable, non-experiential, or verifiable experiential, and later revised these classifications to non-experiential fact, experiential facts, value and policy, and also reference. This is really close to our set of classes. And on this data set, finally, Nikolai in 2018 in his PhD thesis achieved a maximum score of FE1 score of 0.74 for preposition classification using SVMs. This constitutes the baseline for this work, in spite of being applied to a different kind of text So because ours is newspapers, opinion articles. So our data set is, as I just said, is a set of opinion articles published in a newspaper. In this case, it is public newspaper. It also includes so 16,000, almost 17,000 entries of annotated components for arguments and labeled according to 5 classes. We reduced these 5 classes to 3, so we don't have the polarity treated in this project. And analyzing the data set, so we identified 2 challenges at the beginning. So each article was annotated 3 times by distinct annotators. And that means that we found different delimitations of the same propositions. So the starting character and the final character were not the same. And also when we have the same classification, the same delimitation, so the same component, we have different classifications depending on the annotator. Another challenge was that the class values were unbalanced. We also identified some hints to apply natural language processing tools. And for example, for policy, we noticed the presence of verbs in imperative mood and modal verbs, which suggests the use of POS, lemmatization, so those kind of normal tools to resolve these issues in NLP. Facts, we have presence of numerals, entities, and value, we have presence of evaluative adjectives. So if it is balanced, strong, strange. To solve this, so to highlight these patterns, we used LinguaKit, which is a multilingual suite of natural language processing tools. And it was developed by the University of Santiago de Compostela in Spain, but it was not enough. So we have some specific taggings that compensated some shortages of LinguaKit, like in the model verb forms identification, and some kinds of numbers and currency symbols, etc. So our pipeline is this one. So it's quite typical for natural language processing machine learning issues or problems. We had the processing related with LinguaKit, so natural language processing. Then we split the training test data, and we used a certain number of machine learning algorithms to find the best performance, and then applied the best performance algorithm to the test set. So in terms of results, and just to assess the problem of having several annotators classifying the same components, we have more than 1,000 pairs of records that refer to the same proposition, but with different levels, so with different annotations. And the most conflicting ones was between value and facts with 951. So this also suggests that even as these annotators were linguistic experts, this suggests the difficulty to classify this kind of components in natural language. Okay, our results in terms of the algorithms are these ones. So the algorithms are, most of them are quite close one to the other. And there are, if we take the different metrics, each one would bring us a different winner. So it was not easy to decide which one of them would be the best. But anyway, we selected from these ones the SVMs, the random forests, and also the GB. And these were the results on the final model. So at the SVMs, we have the best macro average FE1 score with 55.42%. For the micro average, we have, sorry. For the micro average, the best result was the random forest, and for the weighted average, also the random forest did the best. No, sorry, it was the gradient boost algorithm. So just to compare it, to decide which one would be the best, we compared two cases where the metrics somehow gave us different results. So if we compare the SVM results, we have a macro average of 42%, which is the best. But if we consider the micro average, it would be the random forest model with 74.30%. Nevertheless, if we look at the coefficient metrics, it's obvious that the model on the left is better because it will perform better in all classes and not only on the most frequent one. And this has also to be has to do with the type of metric used and the bias that is introduced by the micro average in terms of when we have unbalanced data sets. So this is so our final performance is 55.42, which is below the baseline of 74% for English. We think that this might be related also with the inconsistencies that we found in the data set. We think that the impact might even be higher than the one we could calculate because we didn't consider the overlapping, the limitations, but with different labels in the data set. And to explain this difference, I think we should also analyze further the corpora that was used in English for the same inconsistencies to see if they are the same or not, and also compare further the approaches to approximate the methods and tools of both approaches. So in terms of conclusions, we built a classifier for argumentative discourse propositions in Portuguese, which, as far as we know, was the first one. According to those types of classes that we taught before, value, fact, and policy, we think we set a precedent for further exploration of combined applications of natural NLP and machine learning techniques, combining with the periodic table of arguments, and in Portuguese. As future work, I think we can improve the performance of the pipeline with further parameter tuning, solving the inconsistencies in the data set, or as an alternative, associate probabilities of labels based on the frequency of the annotator's opinions, and also applying other techniques like TF-DF or other algorithms involving neural networks could be of help here. So this is my work. Thank you. I'm open to questions.
Thank you, Tiago. Professor Augusto, what's your opinion on Tiago's work?
A good opinion. Okay, Tiago, it was a nice presentation, clear presentation, let's say, with 15 minutes, more or less, yes. So in time also. You started with your agenda, conducing the explanation, presentation for the argumentation. The introduction described exactly this. The introduction was perhaps a little long because in the introduction you made some related work also in the introduction. Not bad, but it was a little extended, the introduction. In the opposite side, the label related work was very short. And immediately you went to the state of the art, remember? So perhaps here you could balance better both things. The introduction is to present the problem, to make the context, to present the motivation also. Why am I working on this? and after that related work and the state of the art. Related work is that kind of things that is more stable. The state of the art is the state of the art, is what is the best in the area. You after that you described the data set. The set is composed of things extracted from the new papers and annotated by three
annotators, yes.
Annotators, but you used an adjective that I was trying to remember.
Don't remember.
After that, approach with your pipeline, etc. For this approach, is there any variation that could be better explained? The pipeline is too fixed, each block exactly that, and in each block, can we have some variations? Could we have some variations in the sequence of blocks? Can you explain this, and should this be discussed also or not?
The variations in terms of sequence?
In terms of sequence and in terms of each block, if there are alternatives in each block.
There are alternatives that could be discussed. Yes, and there are.
This is.
Yeah, it was just the way we decided that, but it could be we could use, like, we used a tool like LinguaKit, so we could make an assessment of other tools of natural language processing and see if there are other tools and they perform better than this one. Yeah. We could analyze further the data set in terms of frequency of patterns.
My advice, Tiago, my advice is even when we present the solution, this is your solution, your approach, okay?
Yes.
You should, at least in the main parts, explain why we decided for this, we decided for that.
Yes.
Okay?
Yes.
This is science. Otherwise,
yes,
it's your opinion only. Okay?
Yes.
After that, you entered the results.
Yes.
You said in some part in slide number 18, it says one. No, next one. It's difficult to decide the best. Okay, but there are some figures here, some numbers that indicate what is the best in each case. Okay, usually we present the best cases and the worst cases also sometimes with some different color, bold, italic, something that makes better the visualization of the best cases. Okay, just a detail in the presentation, but can be
to highlight the results.
Yes, I highlight the numbers. That's it. After that, you went to the discussion, further discussion comparing Portuguese and English. And I don't know, is this the future work for this development of yours?
The future work
English versus Portuguese and relationship between both?
Yes. So
further research should compare.
Yeah, the one of the following steps would be that. So to compare further what our colleagues researchers did for the English case that we have as baseline, and see what are the differences, and try to diminish to experiment with the tools that they use to see if we can improve our results on Portuguese. Yeah.
Okay, in the last slide, perhaps in the future work, you mentioned also the need to solve inconsistencies in data set.
Exactly.
The data set is what it is, isn't it? I mean, solving inconsistencies is something like change the data set, in my opinion. I don't know. Is this so important?
Yeah. It is important because we are classifying the same thing with the different labels, right? So it's going to be always difficult for these algorithms to deal with this. So when I mean solve, it's not to modify the data set. It's probably
a different thing. It's detecting the inconsistency,
detecting
and in some way the work.
And I don't know if we could work with the annotators and then provoke a debate between them and for them to find a solution, but I don't think that's the thing here. What we could do is, if we have 3 annotators and we have 2 that vote for one label and the another one vote for the other, we have 2/3 of probability of having one and 1/3 on the other, and that could help us to feed new algorithms and have at least a probability of the label to be predicted.
Having your algorithms prepared to work with these inconsistencies, but not changing the database. Okay.
Yes.
Thank you, Tiago.
Thank you.
Thank you very much.
Thank you, Professor. We're already going overboard with the time, but I'm just going to ask you a question from the audience. This question was asked by José Borges. I apologize to José. I'm going to rephrase your question. I think there's here some typos in your question. So if I understood your question right, how exactly are the relations established between the different argumentative discourse units? For example, the attack and support relations. How exactly are they detected?
So that's first of all, I would like to clarify that the classification of that we approached in this work, it's not associated with the relationship between the argument components. So this is independent of that relationship. The relationship is that the characterization of the relationship is a subtask of argumentation mining. So it can classify those relationships between support or attacks, and that is depending on the content of both components. And we look at the conclusion and we look at the premise, and we can see by patterns, right? So the algorithms will detect by patterns which premise, whether if the premise is supporting the conclusion or if it is attacking the conclusion. So this is the way our algorithms and also us humans detect if a certain premise is supporting or attacking a conclusion.
Okay, it follows the same process as our brains.
Exactly.
Okay, thank you, Tiago. So I still have here a couple of interesting questions, but we don't have any more time. So the rest of the people, I recommend you to contact Tiago Mendes directly. It was a very interesting paper. Let's move on to our second work, which is about text mining and classification, and will be presented by André Gonçalves. André, the microphone is yours.
Hello, and good morning, everyone. I'll just take a moment to share my screen. I hope you can see my presentation now.
Yes, thank you, André.
Okay, thank you. So my presentation, my work is titled Supervised Text Mining Approach for Automatic Text Genre Classification. And I'll go over the contents real quick. So I'll make a brief introduction and explain the motivation behind this work. I'll cover the related work on the area before passing through the experimental section, where I'll go over the data sets, the pre-processing steps, the classification models I used, and the evaluation metrics. I'll explain my results and provide a discussion before concluding the work and presenting future ideas for follow-up studies. So, starting by the introduction, the task of automatic text genre classification consists basically in automatically classifying a text document according to into a set of predefined classes according to its extralingual features by the means of a machine learning algorithm. It basically involves the steps of defining a universe of possible genres that a text may fall into, detecting any significant words or features that are external from the content itself of that text to reflect the text functional characteristics, and thus extracting patterns that allow the classification of these texts into the same pre-established categories that we assumed as possible. So while there is no high consensus of a formal definition of text genre among many authors, it is widely agreed that it incorporates the text characteristics in terms of register, functional style, and communicative goals, among many others, to provide an idea of what that genre is. So, regarding the motivation for this work, why is it important to automatically classify texts according to genre? And there are a multitude of answers. Firstly, as I just said, there is no high consensus between researchers regarding what makes a text genre. So by unifying classification criteria, it would help in reducing human bias when classifying texts. Text classification in regards to genre would become more standardized. Secondly, it would exempt the need for manual labor and specialized experts in linguistics, for example, to carry out this task, since a machine would do it appropriately. And it would automate the burdensome and often time-consuming task of categorizing large corpora. Third, by compiling wider and more diversified, we can compile wider and more diversified corpora if we can sort of take out of the equation the variability of genre, if we can account for it properly in our studies, which leads us to our fourth advantage. By improving the performance of other NLP tasks, it can improve the performance of other NLP tasks if we can provide a certain document with an accurate and informative genre label that is reliable, since we know it was obtained in a standardized manner. Going over some previous work on the field now. The first work on genre detection, I believe, is attributed to Bieber and colleagues around 1986. And he used factor analysis in a set of syntactic and lexical cues to carry out the first sortings, not between text genres themselves, but between written and spoken language. He characterized linguistic features as informative or non-informative, narrative or non-narrative, for example. And his study was followed by Karlgren and Cutting in 1994, who discovered new structural cues and simple counts of third-person pronouns carried out with discriminant analysis to sort out these genre differences. So by assessing the amount of third-person complexity within a text, he could carry out this sorting of genres. Kessler in 1997 moved out of the expressed structural cues specifically and revolved the subject by introducing the concept of genre facets, which were, in this case, character level cues such as counts for paragraphs, delimiters, punctuation marks, and numerals, and also other metrics regarding the length of words and the length of sentences in the text, which it could correlate to the genre of the text he had at hand. From the year 2000 and on, these works on text genre classification evolved a lot and started taking into account part of speech tags, using word embeddings and more advanced NLP techniques in order to predict more accurately the genre of text. For example, in 2001, Diogo and colleagues already were able to propose various models based on naive-based decision trees and support vector machines, which are standardized machine learning techniques for supervised learning used nowadays, to train on an immense amount of textual features. More recently, more interesting works on the field of genre detection include that of Li and Mi Yang in 2004, who combined training data to distinguish between both genre and subject within a text with a statistical classifier. Schoolman and Barbosa, who managed to carry out a successful classification of text genre using parts of speech tags alone, and Strobel and Kurtz, who created a tracking window of complexity within a text and were able to detect the genre of texts according to the progression of complexity across the body of a text. And as such, the main objective of this work is to tackle on the challenge of text classification and construct a supervised multi-class classifier that is capable of categorizing documents from different backgrounds according to their textual genre. Going into the experimental section now, our data set is comprised of 2,000 web collected texts belonging to 5 different genres selected by us in a balanced proportion of 400 texts per genre. The trained test split was 80-20, and the selected genres were argumentative essays on various topics, news articles on topics such as sports, politics, economics, and so on. Movie reviews, namely movies debuting after the 90s, I think. Scientific abstracts on subjects such as physics, biology, medicine, and engineering. And also short narrative stories from classical authors. And moving on to data preprocessing. The preprocessing of these texts followed the standard rules for natural language processing. So it included the removal of paragraph marks and indentations, lowercase conversion, removal of special character, exclusion of uninformative stop words that create noise in the text, and finally tokenization and vectorization for the vectorized formal representation of these texts. Feature extraction was performed simply using the bag of words model. The bag of words is the most simplified method, I believe, to extract, to vectorize and extract information from sentences in a text, since it simply transforms the sentence into token counts. But on top of this vectorization technique was applied the term frequency inverse document frequency technique, which was used as a statistical tool to weight the prevalence and importance of words in a given context. So not only did we address the counts of words in a given text, but also the importance of those words in that specific text in regards to how many times they do not appear in different genres. Moving on, we chose as classification models the multinomial naive Bayes as a baseline technique. So as a rather simplistic model, the naive Bayes calculates the probability of encountering a given text in a given genre as the product of the likelihoods of the words belonging to that text to figure in the same genre, so across the rest of the bodies in that genre. Next, we use the linear support vector machine. Support vector machines assign feature vectors containing the text to the label of genre over the given genre or not that given genre, and then fine-tunes the equation of the hyperplane that best divides the observations belonging to each class of data. So it creates an hyperplane that splits the observations of the texts, and by iteratively repeating this process, ends up dividing the 5 texts into 5 regions by a complex plane. Finally, the logistic regression is conceptually quite similar to the support vector machine. It assigns binary values to each class also as genre J or not genre J. And then in an iterative fashion, it calculates the probability of each feature vector to belong to that given genre using a logistic fit. And again, it iteratively repeats this process until all 5 text genres have their observations classified. Sorry. For the evaluation, we use standard machine learning metrics, so precision, accuracy, recall, and F1 score, along with a macro average as an overall measurement across the balanced classes for precision, recall, and F1 score. Looking into the results now, I present in this slide the results for the 3 models across the 5 text genres we studied, so essays, news, reviews, abstracts, and short stories. And we can see right off the bat, looking at the accuracies of each model, that these results were truly remarkable, since the naive Bayes approach, the most limited one, achieved an accuracy of 96.25%, while both the linear support vector machines and the logistic regression classifier obtained an accuracy of almost 100%, and especially did not miss the classification of any review or scientific abstract. The macro average is outstanding as well. And remarkably, they performed exactly the same given their high superposition in this kind of tasks, which was expected in that regard. So what these results tell us is that, again, all 3 models performed exceedingly well in classifying text according to genre. And by a slight margin, the support vector machines and logistic regression models outperformed the multinomial naive Bayes one, and performed equally in regards to these metrics. However, and this is where it gets more complicated, we can see that the classification is exceedingly reliable for such a simplistic means of representation and extraction of data. And this is in direct conflict with literature reports, since the best works in the area, namely those of Dudney and Strobel, only attained a 92% accuracy using support vector machines in the first case, or 95% accuracy using RNN-based models. And now it's granted that these works were carried out with probably very different data sets and contemplating very different genres, but still their feature representation schemes was much more complex, going to the lengths of including function words, character n-grams, part of speech tags, and syntactic chunks. And not only that, but working those techniques in a synergic way to obtain these results. So what's the underlying issue here? Well, basically, it's one of, in my opinion, one of the classic cases where if it's too good to be true, it probably is. I could come up with 2 possible explanations for the success of this algorithm, which regard the size and complexity of the dataset itself, which were insufficient to generate a contentious classification of the different texts. So the underlying issue is that the datasets, not being too extensive or complex, so to speak, could not recreate the difficult task that is often characterizing a text according to genre. And as such, by comparing, for example, a short story, a short narrative to a news article, or a review to, again, a short story, it might have been too easy for the algorithm to distinguish well between these 2 types of texts, and thus the classification task we created is not realistic. An alternative is that words in this work were treated as isolated entities because of the TF-IDF / bag of words representation. And as such, the syntactic use and all the grammatical structure of the text is lost in this transformation. And being as important as it is to define a genre, probably something we cannot do in this task is completely abandoning the grammatical meaning, because we will be resorting only to topic-based information. So while one of these options might be more prevalent than the other, I believe the two of them contributed to the skewing of these results. And as such, I believe the obtained classification might not be truly genre specific, since it probably contemplates other factors that are underlying in text classification, such as topic or subject. And these are not entirely separable from genre, especially in a simple experimental setup like this. So moving on to conclusions. I believe we can say it was not possible to discern if text genre was truly the main factor guiding the classification, or one of the other factors I just mentioned. But the utilized models and feature representation technique can be deemed appropriate for such simple text genre detection tasks, where, for example, classification on terms of genre or topic or subject, or even other unforeseen criteria, which might have been on the basis here, may be overlapped due to the simplicity of the setup. And finally, I will conclude by presenting some future challenges in order to tackle these difficulties, which are to contemplate, firstly, a wider range of text genres and subgenres in the classification problem, but also integrate topic defining features in parallel to genre defining ones, so as to eventually detect and exclude this kind of bias that might be shadowing the results and the classification itself. And finally, to expand the feature extraction methods in order to utilize techniques of higher hierarchy, such as part of speech taggers, n-grams, and word embeddings, so that the true grammatical features and underlying relations within the text may be properly captured. I believe I reached the end of my work, so thank you very much, and I'll be glad to take any questions from now on.
Thank you, André. So as usual, before moving to our audience's questions, I'll pass the word to Professor Augusto.
André Gonçalves, nice presentation, a calm presentation, more or less in time, only 2 or 3 minutes more. Let's say introduction, defining that the problem is the text genre, the motivation in questions why I am motivated for this. It was nice to see. And immediately you went to the related work. In the related work, you divided the related work in 2 steps. First, the early stages and modern styles, if you permit me. Yes, that's it. First, I enjoyed this presentation. Okay, each rectangle is a reference. Okay, each rectangle is a reference, and for each reference, the main guidelines, the main ideas of that reference. Okay, for a person that is seeing, immediately understand the sequence, the evolution of things. One thing not so good is, obviously, the space is limited, and you decreased the size of the font in the right side, and in a real projection, it could be difficult to show this text. Okay. But the principle is very good. Also, when you change to the next slide to the modern styles, it looks a little unbalanced. The previous work, the old work, and the modern work. Okay.
Yes.
You reinforce it too much. The above work perhaps facing the modern work. Okay. Yes. Under the historical side of the problem, it can be a good thing, but for the explanation, for the scientific explanation of your work, it would perhaps be better to concentrate more in the modern styles either than in the past ones. After that, you went to the objective. Yes, well defined. And the data set. Okay, the data set was large and with several categories, and you decided, you or some someone decided for these 5 categories. And I would like to know if these categories have some particular importance, or if they are only randomly chosen. What do you think?
To be honest, I went into a bit of thought in order to select the categories. I believe I selected them myself. And my objective was to see, first, to create different enough categories that I believed could be useful to help my algorithm actually distinguish genre and not another unforeseen criteria. But also, I was trying to provoke, so to speak, the algorithm to maybe make a mistake and classify text genres that I consider to be more alike one another, like that. So for example, news articles and scientific abstracts are both expository in nature. So I would expect, for example, the algorithm to maybe mistake news with scientific abstracts. And similarly, argumentative essays have naturally a lot of argumentative burden, so it could be confounded with a review in which arguments must also be exposed and defended. Finally, short stories, I intended for them to be the outlier among the rest because it's the only non-literary, the only literary narrative group. And I could perhaps see a very good classification of short stories, but not so much for the rest. So unfortunately, due to the nature of those results, this was not verified, but that was the original goal.
Let me relate this with in the discussion. You try to explain with 2 reasons why your results are slightly different from the standard results presented by other authors. Couldn't this be related to these chosen gems?
Yes, and that is one of the main thoughts I had included when referring to the complexity of the data sets.
Okay.
So while there are much more than 5 textual genres to consider, perhaps, as I said, by defining and sorting these texts into only 5 genres.
Do they use only a small set of gems, or they have a larger set?
I beg your pardon?
Do they, the other authors, do they use also a small set of gems, in your case 5, or do they use more, 5 or 6?
Actually, I don't think I encountered any author that used 5 specifically. I encountered authors that used 2 and carried out the distinction between those 2, and encountered authors that used many more than 5. So I believe those are the 2 main paradigms.
Okay. Continuing, after that you went to the data processing, so you started explaining your own work, and in slide number 12, just to say that I enjoyed also this, in the same line of the slide, the above slide, explaining your the alternatives and showing the advantages of each one and the problems of each one in a clear sentence, a short sentence, summarizing, making the thing easy to read and to understand. This is also a good thing in your explanation that I should remark. So the problems of different results from other researchers have been already discussed. Let's go for the conclusion and future work. Wider range of types, but you have other problems to solve, namely the difference of your classification facing the classification made by other authors. Do you think that now is the moment to go for a wider range of types of gems?
I'm afraid that if I refine the sorting techniques on the same data set, I might not be able to compare the results with results that I consider to be skewed. So I don't know if I should be happy by carrying out, for example, feature extraction with part of speech taggers or any of the methods I suggest on the third bullet point. I don't know if I should be happy to see the accuracy of the models, for example, to decrease, which should be a bad thing, or to maintain the nearly flawless classification, which would not be very informative because it doesn't objectively tell me that these techniques are better than the simplistic ones I employed.
Okay.
So.
From your presentation, I enjoyed your presentation. I enjoyed your slides. One or two, this one, for example, but in very rare case, longer sentences, but sometimes we cannot avoid them. Okay, the size, except in that picture, was size of text was good. A good presentation, in my opinion. Thank you,
Okay.
André.
Thank you, Professor.
Thank you, Professor. Unfortunately, we're already on overtime. I have here a lot of interesting questions, but we still have one presentation. So I think we'll end your question and answer session here. Just so you know, just to satisfy your curiosity, some of the questions here and some of the questions I also had prepared for you were related precisely to how good your results were, trying to find an explanation why your results were that high. But
yeah,
okay, just so you know, that was the.
I'm trying not to brag a lot about them because I know they are not really that good.
Yeah, it's important. It's important to have a critical point of view, and you were able to identify those nuances. So good for you. Congratulations. So let's move on to our last paper of this session, which will present an application of natural language processing in the area of accounting. And this paper will be presented by José Borges. José, the stage is yours.
Okay. Hello, good morning. Okay. Good morning. I will be the last one, so I will take briefly my presentation. As Gonçalves said, my presentation is about application NLP techniques in accounting. What we're going to talk is about 10 steps: the objective, the state of arts, the original, where we get information, how I implemented these, what was the problem of data sets, the results, and some discussion and the future work. Okay. So the objective of my work is to think about it. If we try to implement a cognitive system in accounting with the NLP technology, what is the careful that we have, that we need? What is the problems that we can take? And it's the first approach. Okay, so where we get the problems. In the state of arts, I will study four different chapters. Intelligent system that are used in auditing enterprise, where is a system that takes steps. And if something happens in the first step, the system proposes a solution. Okay, in the accounting program, the usually is to get some macros to repeat steps and to get a list of work to be done for someone. The other two chapters that I studied, it's about robot processing automation. It has in the beginning of the study because we have a problem of quality information. Because if we get some robot processing and the information is not good, we can get some mistakes, some problem with mistakes. And another chapter that is study is the cognitive system with the assistants like Google or Siri and other stuff like that. This study are in the beginning. in the business ambient is in the first steps and some problems that we can have. Okay. So in the counting, we have the source of documents. We have different types of documents. The main problem here is that it depends of the documents, it depends of the way it's written. We have some values that could mean different things. For example, if you have a material transaction, the paper is the same, the text is the same. Only change a little words like buy or selling. If you have, for example, money transaction, it's you can think in three different transactions. And for example, as we all know, when we receive some bank statements, the information that could be in that paper could be the information that we see is the same, but the meaning could be different statements. Okay. So in our work, we retrieve information from real documents. We do this by two main steps. One of them is the OCR of the documents. We make the scan of the documents. We work very in the text documents. The QR code that is by law to be implemented in the next month it could get some help to us. And we have electronic documents that in our case is not to worry, but only to unify information. Okay. In our implementation, we have 3 steps. The first one is to get information, and in this we work with OCR, the TerraC and OpenCV library, and ADE we only preoccupied with getting uniform information. Okay. In the step number 2, we have to try to classify the documents, because we think that to get information inside the documents, we need to know what type of documents we are. The same information in an invoice is a different meaning to have the same information in a credit note or in a letter or in someone else. Okay. So in this information we work with in this phase we work based in a file, a text file, normally a text file, and we try to identify several documents. We have some techniques to eliminate some noise in that document to make a real classification and try to solve some of problems that we have in the next slide. Okay. And in the phase 3, after we had the document in the information in an electronic way, after we get to know what type of document that we are in the present, we will go to the next step, that we try to identify information inside the document. So in this picture we have the steps. We have the first of the document. After that, we try to make a simple OCR. We have some raw text, and after that, we apply NLP techniques to try to know what type of information that we have. In this phase, we have some problems, because when we try to recognize some patterns, we have 2 types of the patterns, as we're going to see in the next slide. Okay. After that, after we make these three steps, we finalize with some information, with some information with this. We try to not to lose. We try to not to lose information in these 3 steps, and we use this format Palo Alto, that is XML file that has information. Like position of elements, like localization of the elements of some items, and we try to know what type of text that is. Okay. Our work is based in 2 real data sets. This two data sets. I scan the documents. We're going to see what is the problem, because I have the first one data set with about 200 invoice and 25 other documents. The second data set, I will have more careful to make this, and we have 250 invoices, 15 credit notes, and 10 banking strats. Okay. The results in the phaser one is not. It's a good result. It is in the same line that is in the market, because you use libraries that are very stable in the Python and in the OCR technology. What we see that if you apply some filters, if you try to get out of the noise that is provoked, for example, with the color, we have 20% more results, good results with less noise, because the OCR or the system don't try to understand the colors of the paper. One of the main problems is that, as we show here in the feature, in that picture, is that if the document is not in the right position, the OCR could have some difficulties to get information. With these libraries, we have a good result with this type of technology. Okay, in the phase number 2, we have some problems in the beginning, and that's the reason that we have two data sets. As my previous colleague has talking, the André Gonçalves, I have the same problem, but I think I try to understand what is the problem, and I get some results, some good results. For the first data set, first in this phase, I try to compare two main protocols in classification. The MEL protocols, where we use native veins with counter words, TD-NDF, and TDF and grams, and we try to compare with neural networks. Okay, and in this moment, we have one problem. With the first data set, the results that we get, it was not stable. It was a random results. We tried to apply that. For example, with the first data set, we take a model. After that, we try to apply that model in the real world, and we have some random results with the accuracy jump to 50 to 90, but with the same result, with the same documents. So we try a different approach. We make a new data set. In this data set, we try to get more carefully in the documents. We try to make some real world statistics applying to these documents. If I can remember these, for example, here in the first data set, we have only 200 invoice and 25 other documents, but these documents are not classified. So the native, so the model wrong classified documents. With this, in this section, in the second data set, we have 200 invoice, and we try to that percentage of these documents. It was some real. What we do in this manner, we try to scan the documents in different companies. We try to scan the documents in all month. And we try to classify these documents in the same way. Okay, with this new data set, we have this accuracy, 97% of the accuracy of this model. So I think it is a good result to take in account. In the three phase, we look for patterns. For example, in this, we look for two two types of patterns. The first one is that we know, for example, the VAT number has some patterns, 9 numbers and some initial letters. So we project the model to try to find out this type of information. The other one is that with the XML and the XI coordinates, we try to know more information. And if we know, for example, that some words, and after that we have the number of the invoice, we try to localize to try to get the real information. Okay. As a result, we have this percentage of the accuracy. Okay. So the problem is that when you try to use RPA, we have some problems with the accuracy of the models. We need to be careful to the data sets if they are unbalanced. So if you are working with unbalanced data set, we need to take carefully of that imbalance, if it is a real imbalance or if it is an imbalance that we are created with the wrong data set. Okay. But we try to take a point with the real statistics with this. Okay. For future implementation, we try to get a more quality information, and we get to try to analyze a complete implementation of the RPA with some cognitive capacity. I think that is what we are to try to say, that after we have quality information, a good quality information that we can retrieve from the documents, we could get some robot or some system with robot capacity, with the cognitive capacity to get information from the documents, and not only make some steps, but to try to make decisions and to make a good decision, a good help to the user. If we don't have quality information, the RPA will not be useful, and we'll try to get some wrong decisions in the meanwhile. Okay. Maybe where I get information is that in this moment it is an issue with with some papers, especially in the account professional, because with this implementation, the type of work that that kind of people is doing is very changing every day. For example, what they work in last year in this year is completely different. Is much more automatic way. It's more recursive and more important, the information system that is in this moment. Okay, and for now, thank you. And if you have any questions.
Thank you, José. So this is our last presentation. Professor Augusto, what do you think about this, our last presentation?
I think well. Thank you. José Borges,
it's always a good sign.
Thank you very much for your presentation. It was a good presentation. Obviously, you are like me. Your English is not perfect, okay? We are in the same side. You have to improve a little your English in oral expression, but also in reading, in writing texts. I saw some misspelled words. For example, you swapped bibliography with biography. This is one. And another one was I believe that your intention was to write good results, but one O disappeared and it became God results. Okay. José Borges, about the presentation. you started presenting the agenda, defining what is an NLP in the area of accounting, what is your objective. You mentioned some state of the art, but you forgot to tell the references, the main references of the state of the art. Now, at the end, in the biography, you mentioned the list of papers, but let me tell you one thing. In the bibliography, it is important to mention the year, okay?
Okay.
You have the author, you have the title, but the year is also very important, and obviously also the place where it was presented. So we have standards for this. After that, you explained that what is the source of documents, different types, etc. And you want to take information from these documents. And the first thing that you mentioned, the first phase was the process natural or documents in paper, let's say like that. And you need to make some OCR work to recover the contents in the electronic format. And you mentioned this in your exposition. You mentioned some problems that you had during the development with this phase. And I would like to say that this problem, this OCR problem, is an old problem that is much solved. One problem, for example, that you mentioned, that is the document that is distorted, is completely solved. Any software that makes OCR solves this problem. So I don't know if you should concentrate on this, or you should simply use a technology that is available, making the OCR of the documents and process after this, okay? It is perhaps not good scientific work nowadays. So you can use this time, this effort of yours in other parts of the work. You use the two data sets, real data sets, okay. And one thing that you mentioned, and with some reinforcement, is you have an XML file that describes more or less what is in the document. In this rectangle, I have this information. In that rectangle, I have with coordinates, with some words, etc. But let me tell you, this makes the problem. No, this makes the solution, your development, too much fixed for this type of papers. For, let's say, for a bank, okay? If you change the bank, or if you change, you have to make different things again. And I would like to know if your objective is to make a general solution or a specific solution for one bank, for one accounting enterprise.
No, the question is very simple. When we pass these blocks or this type of information, is the system that will do the work. We don't. That's different in my paper. We don't choose these. Okay, we do the simple OCR. The OCR knows that he is a text and recognize these types of text. And in the XML file, we only get the information that in this, for example, in this square, we have some information here. For example, if we know, one of the things that we do, okay, here. For example, the VAT number is easy to know because we try to look for 99 numbers. But the number of invoice, we need to go to this square, and after this square, we need to know what type of word of information are here. We don't in this work we don't classify the paper with these blocks. The system will need to know. It's not us. So the system is open, and the
blocks are not fixed.
The blocks are not fixed. No,
The area for the invoice is not mandatory to be that area. Can be in other part of the document.
yes.
That is not what I understood.
The idea is that
fixing with the XML file.
No. That's the problem, Professor. That's a problem that because if the document is not, if the system of Dsie is not right, if you get some angle, the square could be, for example, the information could be in another square, and the system get difficult to know that information belongs to that chapter. For example, the date or the number of invoice, we have some title to classify the information, and we need to know that automatically the system recognizes this square, and in this square is the word invoice or number or other word, and the system needs to know to learn that after this word is some number or some code and consider that number as a code. We try to do much open, not to learn the documents in the open paper, not in the try to find blocks.
Okay, my misunderstood. I'm sorry for not understanding well your presentation. In the discussion, I would like to say that I see that in the future work, including the cognitive capacity, I think that this will be the best development that actually this work will have. Is this your subject for your thesis, or
Yes.
one part, or?
No, it's that subject of my thesis. It will be the part cognitive applied to this system to get some information about the quality of information, and after that the system with cognitive capacity will analyze and say, okay, this is right, and try to learn from what some users are doing, and try to get that in the inside of that brain, and try to do something like that.
Okay, the time was more or less perfect. Some slides had a small size in the font. Okay, trying to put too much information has this result. Have
Okay.
this into account, please, in the next presentations. Okay, thank you very much, Borges.
Thank you, Professor. We're already running on overtime. I have here a question, a very interesting question. I will just ask José Borges, please answer as most concisely as you can. So Fernando Freitas commented that your results present the general accuracy for the two data sets.
Yes.
Do you have an idea of what accuracy you obtained for different types of documents, for invoices, credit notes?
The result is almost the same. Okay, the problem is that if you get some good data sets with some statistical relation documents, the results are almost the same. The problem is that when we work with the first data set, the invoices are classified with much more accuracy than other documents. So when I present this type of accuracy, is the mean of all the documents, and we have some importance of the quality of information. So the accuracy is more or less to the same documents. Okay.
Okay, thank you. The documents are very similar to each other.
Yes. Yes.
Okay, thank you, José. So this brings to an end our second session on natural language processing. I hope you enjoyed these two sessions in NLP. I found that the presented papers on both of these sessions were very interesting, because if we look at them as a whole, I think we can see how this field of language processing can be used in a very wide array of applications, legal documents, to movie reviews, to the bill that we receive every month. So thank you guys for your wonderful presentations. I'll now pass the word back to Tiago.
First of that, An applause
Yeah.
for the speakers and for the share, okay?
Yeah,
Thank you.
well done, guys. Thank you, Gonçalo. So it's the end of our presentations of our science and our research. I would like to thank you, my fellows of the scientific committee and the scientific committee chairs, in particular, Hugo Oliveira and Filipe Ramos, for the work they've done with the researchers and to organize all the reviewing process that I think Hugo will have the opportunity to detail later today. But at least I think they've made a very good work there. But okay, but let's get back to Earth now. I believe lunch is served in every your home. So let's get to lunch and recover, because we have a very good afternoon to enjoy. So we're going to have a break after the video of the laboratory that we'll be presenting after this, and we'll be back at 2 p.m. And we'll have our invited speaker, and we'll be hearing about quantum computing. So look forward to that. See you there at 2 p.m.
Welcome to InfoLab, the Information Systems Lab at the Faculty of Engineering of the University of Porto. Our mission is to design, implement and evaluate information systems for a broad area of applications, addressing relevant problems in research, industry and society in general. Research and projects at InfoLab cover the topics of information management, research data management, information retrieval, human information interaction, information visualization, and World Wide Web. To do so, InfoLab combines different backgrounds on informatics engineering and information science. We gather senior and postdoc researchers with PhD and master students and other junior researchers in a collaborative atmosphere that leads to top-notch research projects. The current research projects at InfoLab include Dendro, a platform designed to help researchers use concepts from domain-specific ontologies to collaboratively describe and share datasets within their groups. Another example is Lab Tablet, a mobile application that tackles the often cumbersome task that researchers have in describing their research by facilitating the metadata production while also considering the existing standards for its representation. With Ant, a web search engine prototype, we created an original information retrieval framework and workbench for innovation in entity-oriented search. For researchers, academics, and professionals interested in media studies, we developed MediaViz, a platform that aims to provide them with a set of analytical and exploratory resources to answer high-level and complex questions about the online media ecosystem in an efficient, visual, and interactive way. APISA, Entity and Property Inference for Semantic Archives, is a project that works on the 3.5 million records of the Portuguese National Archives using semantic web and linked data technologies. APISA will deliver a semantic model for the information in the archives, as well as a prototype applications for archival description and flexible interrogation. The new archival infrastructure provides application interfaces to streamline the incorporation of new resources and access by international aggregators. Another project that is inherently interdisciplinary is Stop Propagate. Stop Propagate uses artificial intelligence to help detect and reduce hate speech in online news media. Our prototype provides news organizations with a way to automatically identify hate speech within comments, but also to predict the likelihood of a news piece to prompt such comments in the first place. When it comes to health, we developed innovative tools such as Health Talks, and health suggestions. The main goal of these tools is to improve the access and comprehension of health information by lay people. Health Talks is a mobile app that helps to manage personal health information, recall physicians' advices, share the advices with someone of trust, and clarify the information provided in medical appointments. Health Suggestions is another Google Chrome extension to assist people searching for health-related subjects in the main three search engines, Google, Bing, and Yahoo. It suggests related search queries in lay and medico-scientific terminology using English and users' native language. These are a few examples of what can be achieved through interdisciplinary research. And this is what InfoLab is all about. A place that brings together teachers, researchers, and students with a true passion for developing projects that impact the community.
you.
SelSus stands for Health Monitoring and Lifelong Capability Management for Self-Sustaining Manufacturing System, with the aim to reduce costs, increase OEE, but even more important, to increase production reliability. 15 partners from 6 countries approved the applicability of this solution on component, the system and the line level.
SelSus project for us was important to understand and to learn about asset utilization, because implementing SelSus in the press shop, in particular in our press line, up to now we are able to know exactly more about asset utilization, about predictive maintenance, and also we are able in real time to display the performance of the equipment.
Poor quality results in disruption on the production line, test failures, rework actions having to be done on engines, and ultimately this leads to ongoing costs for Ford, as well as possible quality issues in vehicles in the future. So the aim of SelSus is to address the root cause of these problems, which is the issues that develop here in the dosa. So SelSus has added a number of sensors to these machines, such as these hydraulic sensors here, temperature sensors inside the working area, and these are monitoring the characteristics that the machine is showing throughout its cycles and looking for trends that are signs of deterioration. All of this data is uploaded to the cloud-based system.
In case of Harms-Wende, the main market is the automotive industry. In this automotive industry, it's very important to reduce the downtime because each downtime costs a high amount of money. For this, we developed here an algorithm to reduce this with the limping home mode.
This limping home mode, the data which are provided by Harms-Wende via the cloud services, we can use as AEFEUP to reduce the dynamics of our linear axis and therewith prolong the overall lifetime and reduce maintenance and therewith costs as well.
So equipment health is very important for us. The SelSus demonstrator is one of our flagship demonstrators in that area. And some of the things that it does for industries, it enables them to spend less time in non-value-added activities, for example, investigation of failures. By providing more information, it means that the operators can perform their tasks and activities quickly.
Here we have our SelSus demonstrator cell. It is a self-monitoring device that can self-heal from a catastrophic event such as a collision. So this is the collision that is programmed in. From here you can see that the springs have retracted, and this is now doing a pressure test to make sure that it has fixed itself correctly.
Yeah, okay. Okay, welcome everyone to our 60th Doctoral Symposium in Informatics Engineering. Our speaker this year is Professor Koen Bertels. Brief description of Professor. Professor Koen Bertels currently is a professor in the University of Porto and also the University of Leuven at Belgium. And he was previously a professor at Delft University and had responsible for quantum computer architecture lab. His research activities focus on quantum computing and more specifically in the definition and implementation of scalable quantum micro and system architectures definitions. He is the founder of a company called QB. I also was aware of this, a company that focuses on specification microarchitectural supports for the control of quantum instructions and how the quantum accelerator is connected and integrated to larger system designs, and how classical and classical logical are combined with quantum logic through the specification of new programming language such as OpenQL that corresponds to a template for the microarchitecture, and the QB simulator to execute any quantum logic operations that we want to implement. So he is a widely respected and influential researcher in quantum computing, and he has many publications related to the quantum application algorithms and related subjects. And I'm really excited to have him here today to give us a talk about quantum computing. So, Professor Koen, when you are available, please. Thanks.
Okay. Thank you very much for the invitation. And I do hope that I can bring an interesting story. I will try to respect as much as I can the timing. So I'm just going to make sure that I'm looking at my clock in a correct way. Yeah. So the goal is, of course, that I will explain what is quantum all about. Yeah, and especially where are we and where are we not? And the not is important, not to demotivate people, but it is a talk really to motivate young people that want to make the move into quantum, because that takes a lot of time, and I will try to understand or to make you understand that. So I will give a quick link with let's say the CMOS technology, yeah, of which we make all kinds of computers these days. And that was first defined by an engineer, Lilienfeld, in 1934. And it took maybe, well, okay, then 14, 15 years for Americans to make it into one particular implementation. But in total, it took us 30, 40 years to reach a VLSI level, so very large scale integration level. Yeah. And it's from that point on that really computers started evolving in a way that led to the personal computer in the 1980s, developed by IBM. And in 2018, these are numbers that you can find on the internet. We have 10 to the power 36 kind of transistors that were made, yeah, and used in any kind of devices. Now, where are we now in quantum? Yeah, I will talk about quantum bits. Yeah, and that's why we also use the word qubit. Yeah, in that you see here on the slide. Yeah, so whenever I mention a qubit, it's a quantum bit. Now, where does the power come from? Yeah, and the way that we look at the qubits is that we can combine them in different ways. So here I'm combining two qubits together as the number 2. So that basically means I have 2 base states in every qubit, and I'm combining two of those qubits. So that means we're combining 4 of those base states. Yeah? That's why I have 0, 0, 0, 1, 1, 0, and 1, 1. Yeah. If I combine 3, it's 2 to the power 3. That means 8. Yeah. So that is very important that we realize that this is how we create a huge computational device. Yeah, that will give us incredible performance. If we look at this number, 2 to the power 300, this is a number so big I don't even know how to pronounce it. Yeah, but I read somewhere that this is bigger than the number of estimated atoms in our known universe. Yeah, so that means not only on Earth, but all of the, I don't know how many planets we now have in our universe, but it's certainly more than 10 or 11. Yeah, but it's so all of the atoms of all of these planets combined, that is a number which is even smaller than 2 to the power 300. So that simply means, yeah, that there's an incredible computational power. And the only thing we need to do to actually double the compute power is to add 1 single qubit. Why? Because we see here 2 to the power 2, 2 to the power 3, 2 to the power 10, which is 1024, 2 to the power 300. But with each additional qubit, you simply double the amount of data that you can work on. Yeah, and this is very important to realize and understand. I put also in big, we are not there yet, but this has the potential. Yeah. Where is my personal background? I will not say too many about, but simply the fact that I started working in collaboration with Intel. Yeah, because that is maybe an anecdote. I worked a lot on FPGAs. Yeah, and I also did the full stack layer of FPGAs, from hardware up to the programming language, microarchitecture, up to an application that you can implement on an FPGA. And when I started on quantum, I had no idea what quantum was all about. I'm very honest. So at some point I had to present something to the people of the research center. And I simply took the same full stack layer, no, modified, but a full stack layer for FPGAs. And I simply replaced the FPGA with quantum. Yeah. And I was insulted by the physics people. Said, I go back to your office, think again. Yeah, but for 1 month later, Intel was visiting. They went to all of the universities in the United States, all over Europe, and everybody who claims to work on quantum. And so they also were passing by Delft. And so I was basically completely destroyed by the physics people. And then I had to talk to Intel. And I said, okay, I have no other ideas, just I will simply bring the same story. And Intel was so enthusiastic about the story because it was the first time they said, we hear how to make a quantum computer. Yeah, did I know? I don't know anything. Yeah, but turns out this is now becoming a mainstream in all of the research centers in the world. However, now I'm start talking about the buts. Yeah, but that means it is an incredibly scientific field. That means huge number of opportunities are there. If you want to start a new academic life or a new research life, then quantum is certainly the good way to move forward. So, but why? Why is that? Yeah, because we are used in CMOS, we are used to having these kinds of errors. And there's these exponents, they should all have the minus sign. Okay, let's be very clear. But that was simply just like the numbers that I'm highlighting here. So if I have 10 to the power minus 15 minus 16, these are the error rates that we have in CMOS, where we use everything for. Yeah. In the quantum physics world, we're 10 to the minus 2, 10 to the minus 3. So there is an incredible big difference between 1,000 and 10 billion. Yeah. So these numbers, these are billiards. That's not even a billion. That's even, I don't know how many powers, but the billion is 10 to the power 9. Yeah. So 10, 11, 12, 13, 14, 15, and 16. These are the errors that we get, that we're used to have to deal with in quantum, in CMOS. Now, how do I see the big field of quantum computing? Yeah, and I started making this actually last year. So I've been with the people in Delft. I've been working a lot on these aspects. We were working with physics people, yeah, trying to make one semi-conducting qubit. Yeah, now maybe we're at 2 or 3 semi-conducting physical qubits. Yeah, and we're already around 2030 for the superconducting qubits. Yeah, but it's always repeating the same kind of thing. So we have to repeat whatever we knew we were doing, and so there was no scientific challenge anymore. So that's why I decided to change to the upper layer. Yeah, to look more at applications for companies, for organizations. Yeah, that means we need to start working with entrepreneurs. We need to look at talk to other people from other fields. Yeah, and maybe at some point, I don't know when that will be. Yeah, we'll reach the quality. Yeah, this is kind of the quality region. Yeah, of qubits that we can start integrating real physical devices in again. But you see that means like there's at least 10 years, and maybe I'm wrong. Yeah, but most likely it's going to be more 15 years. Yeah, but again, that is a bit my personal idea. Now, that does not mean we cannot do anything useful. Yeah. What I think is important is that we need to make a scalable, a quantum accelerator. I don't even talk about the quantum computer because everybody knows, of course, the Nielsen and Chuang book, the green Bible of quantum computing. Yeah, which I think is maybe, and now I'm quoting somebody else, and so I will not mention his name. Yeah, he said, like, I think it's a bad book, a really bad book. Yeah, and then that person decided to write a much better book, which is more from an engineering point of view, focusing on the mathematics aspects, as well as from the electrical engineering up to the quantum engineering aspects. And that book, I've been using that actually a lot in the course that I was giving at FEUP a couple of months ago. Yeah, and that really describes very well what the challenges are and what needs to be done. And I will give you my story of that line of reasoning. Yeah. So of course it is evident we need good qubits. Yeah. Anybody who says we don't need them, yeah, really demonstrates he absolutely understands even much less of quantum than I understand. Yeah. So we need good qubits, but we need also much more. Yeah. So what is the scalability? What is it that we really need? Because we're looking at, yeah, people may claim that they're up to 100. IBM claims that that's 126. Google may claim even bigger numbers, but these are companies that don't have, let's say, a pure scientific objective, but a commercial objective. Yeah. And so they boast, yeah, and is bragging about how many computers they have, yeah, but I don't even know how many we need, yeah. Is it a couple of tens? Is it 100,000? Is it a million? Is it a billion? Yeah. If we look at cell phones, yeah, this has a billion transistors. Yeah. So again, we're at a very low level. Yeah. And that is also why I decided, and I feel that I'm not being alone anymore. Yeah. I start reasoning in terms of perfect qubits. Now, what is a perfect qubit? Yeah. Well, it has these particular two properties. No decoherence, because that means if you put the qubit in a particular state, yeah, and then depending on what kind of quantum technology you're using, ion traps, yeah, diamonds, superconducting, semiconducting, whatever it is, it goes to the ground state. And that is in the best case is maybe 5 seconds by an Italian guy in Australia using superconducting qubits. Yeah, but a very specific kind. So, but he doesn't even know how to go to 2 or 3. Yeah, 1 qubit he understands, nothing else. Yeah, so just to imagine where we are, and we are, it's a very promising field, but we have to do so many things. So that is the decoherence part. Yeah, and of course there also there are operations that we do. Yeah, everybody knows maybe this football, the block sphere, which is kind of 3-dimensional object to represent a single qubit state. Yeah, and all the operations are rotations along the 3 axes in that block sphere. Yeah. Now again, if we do that in the quantum physical way, yeah, these are all rotations of the base states, and we overshoot or undershoot in the physical way. Yeah. So it's never never gives us correct kind of computations. So that is these two things are huge deficiencies, I think. They're huge challenges. But that's for the physics world, yeah. And that does that mean that we computer engineers, computer scientists, mathematicians don't need to look at that? I say no, this is not true. Yeah, we can do many other things. Yeah, we can do when we look at perfect qubits. I will give an illustration later. We can maybe go. We should be able to go now. We can easily go up to, let's say, 50-60 qubits in perfect superposition. Yeah, which is a combination of qubits, or in a fully entangled way. I will not explain the differences between these things because that would take too long. Yeah, but let's say in the superposition way, and maybe we should try to go to 150 qubits. So 2 to the power 150, these are already incredible big numbers in which we can store information. And then what is very specific about the quantum part, that we do a kind of in-memory computing. So we have a qubit which has data, yeah, and normally in a classical computer we use data, we take it from memory, send it to the processor does something with it, and we write the memory back, the data back. That's how any classical computer works. In quantum, it's exactly the opposite. So I have a qubit state, and we're going to apply a qubit operation on that qubit, whether it's in superposition or fully entangled. That we don't really care about that. So, but that is really the opposite thing. So we apply on a particular piece of quantum memory, we apply a quantum operation. Yeah, and this is a fundamental difference between classical and quantum computing. Yeah, I will come back to that a bit later. So this is just an example of how we define a qubit psi, yeah, consisting of 2 base states, 0 and 1. And what you do see is that you have an alpha for the 0 part and a beta for the 1 part. And these alpha and betas, they are what we call amplitudes. Now, again, amplitudes, I cannot give all of the quantum concepts in just 45 minutes. Yeah, but the amplitudes is actually a way in which, well, no, let's first say we can never measure or read out the state of a qubit. What we have, if we have multiple qubits stacked on top of each other in superposition, when we want to read out the memory, we destroy all of the qubit states except 1. And that one we will read out. That's why we always need multiple executions of the same algorithm on exactly the same number of qubits, exactly the same qubits with exactly the same parameters, and run that maybe 10 times, 100 times, 1,000 times. Yeah, still big question mark. Nobody really knows. Yeah, but that is how you need to do measurements after each run. and then you will get some kind of histogram, and the one with the highest frequently measured result is the correct result of your algorithm. Yeah, so this is important. Now, why do I mention that? Is that in the quantum physical world, the physical world, we can never read out a single qubit because we destroy all of the layers. If we simulate or emulate, yeah, we simulate on a classical machine, and I will explain that a bit later. Yeah, we can explain the quantum operation. Yeah, of course, that is stored in classical memory. And of course, I can read out the state of a classical memory. Yes, I can still do that, even if it contains a qubit information. Yeah, and the amplitudes, yeah, they are these parameters. Yeah, in this equation, you see the alpha and the beta here too. Yeah, they represent, written in a different way, the probability with which this particular qubit is going to be measured or can be interpreted as the correct result for your quantum algorithm. Yeah, that's kind of, again, this is orthogonal to the classical world. Yeah, but we have to live with it. We cannot change the quantum behavior. Yeah? That's very clear. We cannot really change that. So scalability also means for me that we need to look at the full stack. Yeah, I think the group in Delft, and that's now talk about 7-8 years ago, we were the first one actually to define the full stack, which made Intel very enthusiastic. Yeah, and which now even IBM is pursuing in its research. Yeah, so we need to work on the full implementation, yeah, of the stack of all of the layers. Yeah, that means we need to make them fully integrated. Yeah, such that we can make an accelerator. Yeah, I don't call that a quantum computer because every single classical computer has multiple co-processors, FPGAs, GPUs, TPUs, all kinds of things. Yeah, and why not the quantum accelerator? Yeah, so this allows us to focus also much more on algorithms. But I will explain about that a bit in a couple of minutes. Yeah, so that is a very, very important kind of starting point. And this is what I still want to bring to FEUP. Yeah, but I really need very motivated younger people. Yeah, can be male or female, I don't care so much. Yeah, but to really start working on quantum. Now, how did it evolve? Now I'm simply showing the kind of graphs that we made from the first weeks that we were thinking about the full stacks. Yeah, and where we are right now, which is this one. Yeah, and I have to say, I'm being in Porto a couple of months during the last 7-8 months. Yeah, allowed me actually to identify new layers. Yeah, and now I think we're kind of okay. Yeah, so these are the two layers where we still need people to start working on. Yeah, wherever they are. Yeah. We are, because we in the group, whatever is left of my group in Delft, we've been working on applications. Yeah, I will give the example later on. Yeah, so we create a library of quantum algorithms. Yeah, we developed our own programming language. Yeah, OpenQL and Sequasm. I will explain that also again later. Then we have the microarchitecture. Yeah, and we also start working on routing and mapping because it's in-memory computing. And you have a kind of let's say a two-dimensional kind of chip layout with topology of where the qubits are. Now there are some constraints. If you need to do a 2-qubit operation, yeah, I need to have in the physical world, these qubits need to be close to each other, and then I can do a 2-qubit operation. Yeah, you cannot put them far apart from each other because then you don't have the control over let's say the electromechanical or whatever it is devices that you use to influence those electrons. Yeah, so this that is why we also start working, and this is the only thing that is still surviving in Delft, where everybody, and I think that is for 90% of the people working in the world, they work on physical qubits. In what kind of technology? Yeah, they all compete with each other and they all claim to be the best. So that means nobody is basically the best. That's my personal conclusion out of it. So here you see also perfect qubits. Yeah, and you see also the simulator. Yeah, I had a master student in Delft who worked on making a new version of the simulator, QBSim, and that basically connects or executes or assumes that all the qubits are perfect qubits. no decoherence, no errors in the quantum operations. Yeah, so this is basically, so this allows us also to make a fully implemented kind of a tightly integrated stack. Yeah, where of course the testing is not there and the OS is not there, but everything else is there. And so that can be used as a research objective, yeah, or a research tool for anybody who wants to step into quantum without having all to define him or herself all these things. Yeah, I mentioned that IBM is also starting to look at the quantum architecture, and I simply I think in 2018 I went to a conference. I think it was a DATE conference. And I was invited to a session based on quantum and organized by IBM. And I remember I was talking to the IBM person. I said, okay, but why don't you have a microarchitecture? And he said, no, we don't need that. No, who needs that now? Because we're just talking about 1 qubits, 10 qubits. Why do you need a microarchitecture? But now 1 year later, in 2019, yeah, they start producing and actually including this particular figure. It's the same figure here, yeah, of let's say the full stack, what they consider to be the full stack layer, from algorithms, yeah, to a quantum processor up to, let's say, the physical processor. Yeah, so that means this is really gaining more and more momentum, and that is always good. Yeah, so I cannot, and I don't want to be the only one to claim these things. Yeah, now, I mentioned already the fact that many technologies, quantum technologies, are in competition with each other. Yeah, and I'm simply mentioning here the 6 most dominant ones. Well, actually, you see here a big X. Yeah, I will explain that. Yeah, trapped ions, semiconducting, superconducting, graphene, diamonds. Yeah, and of course in Delft there was also actually the person who launched the Q-Tech. Yeah, he claimed he was the big discoverer of observing a Majorana particle. Yeah, now that led to a Nature publication. Yeah, and it was like a month or a month and a half ago that he had to admit publicly, yeah, that he did not actually measure that particular particle and that he was not capable of making qubits out of those Majoranas. Yeah, and so. So you see, so there's, and I think that will happen with more technologies. Yeah. So Delft has basically lost one of the 4 technologies on which they were working. Yeah. And I was working only on superconducting and semiconducting. Yeah. I will keep on doing that if ever they advance sufficiently well. But for now, this is not the case. Yeah. So this, yeah, I'm showing this slide actually only to highlight this one. Yeah, that was also like, I think a year and a half ago, I submitted, when I was in Delft, yet another quantum flagship project. I in total submitted 4 projects. Result of being accepted, 0. Yeah, so I did not get any money. Yeah, whatever it is. So I have to start again, and that is why I start now with the company which was already mentioned in the introduction. Yeah, with QB. Yeah, but anyway, I went to Brussels. Yeah, Leuven is not far away from Brussels, and so I spoke to the EU responsible for the quantum flagship. Yeah, and I also mentioned the challenges that we still have to solve. Yeah, and he was actually much more aggressive, yeah, than I was, because I tried to stay polite, and he said, well, if the physics people are honest, they would admit that even 10 to the minus 2 is too difficult for them to reach that quality level. So it's even worse than what I claimed that I thought that we were. Yeah, again, that means that it's an open field, and we don't know which of those. Here I only listed the 4 one, or the 3 plus the ion traps. Yeah, I could have mentioned Majoranas, but Majoranas are clearly out. Yeah, so we really don't know which one will survive and will survive in the market. Yeah, the full stack, the red ones already available. The green ones are still need to be developed. Yeah, and so this is also the QB sim running the perfect qubits is already available. Yeah, now it's of course in the context of QB that is too bad. Yeah, because I have to protect the company too. Yeah, I cannot simply throw everything in the market. Yeah, then I would go bankrupt myself. Yeah. Now, what is it that in QB I want to be doing, and that I also, as a researcher, I want to continue doing? Yeah, is making a full stack. And you see here, this is an entire full stack. yeah, that we want to be making with QB, yeah. And yes, we can move to any kind of quantum technology. Yeah, we already did that in the Intel context to super and semiconducting. Yeah, and we can go to photonics. We can go to any kind of quantum technology. Yeah, because this is more a compiler translation than anything else. Yeah, so that is important for us to, or for anybody who's listening, yeah, to understand. So we basically worked on this. Yeah. This part, the language is there, and on the applications, and of course QBSIM is always there. Yeah, so that is the what we have is what I listed here, and of course we need much more, and I will not keep on repeating myself. Yeah, because I think it's already clear that there's a lot that still needs to be developed that we do in the classical world, and for which we need to find a quantum version, and it's not simply translating anything to a different language. It's really the algorithms themselves are completely different. Yeah, are really completely different. So that is important to realize. Yeah, I know that many students were interested in machine learning. Yeah, well, there is indeed a relatively big field in quantum machine learning. So if you're interested in machine learning, why not look at the quantum version of those things? Yeah, these things are maybe many of them are in the public domain, or maybe you can talk to people who work on these things. So that I think is also very, very important to realize. Yeah, important is what I put here now on top of the slide. Yeah, if you're interested in doing quantum research, don't wait until any physics group in Portugal or anywhere in Europe or in the world will give you good physical qubits, because you will have to wait 10 more years for that. Yeah. So what I say is now every single quantum algorithm runs on a very powerful supercomputer. Yeah, and I will explain that also a bit later as we go on. Well, yeah, actually now, what is a supercomputer? Well, we know that these are the most powerful computers that we're capable of building. Yeah, and this is just the 10 fastest supercomputers. Yeah, of last year, 2020. Yeah, so it's pretty actual. Yeah, and of course, you see who is winning clearly. China. Whether we like it or not, China is making its own processors. It's no longer using Intel processors. Before 2019, they did use Intel processors, but now they made their own processors. Yeah, and look, they're immediately much better than anybody else. Yeah, and so you have some US-based machines, and yeah, but this is a big difference. Yeah, Portugal has also maybe one or two supercomputers, but Switzerland, for instance, has 20 supercomputers in a small country. Yeah, of course, yes, it's a very rich country, blah blah blah. Yeah, that is true. Yeah, but this simply means that if we have a very powerful computer, we can run any kind of quantum algorithm. Yeah, implement any kind of microarchitecture. Yeah, on those machines and test whatever application it is that we need to have. This is a picture I took also from the internet. I think I took it this morning. Yeah, from the biggest, the most powerful machine here, the Taihu Lite. Yeah, which is this machine, which is just one rack. Yeah, after the other. Yeah, in a big room, seriously cooled. Yeah, that is what these supercomputers need. But this is just an example of how such a classical supercomputer looks like. Yeah. Now, what is needed? Yeah, it's not like it's a simple thing. Yeah, because we need to represent the qubits. Yeah. Now, one qubit, a classical qubit, yeah, has two base states. Yeah, the 0 and the 1 can be minus in the plus. Yeah, and there's a third with an imaginary number. Yeah, but basically has two base states. Yeah, so that means for each base state it has an amplitude. Yeah, and so the amplitude represents, as I said before, is the probability is in a way written. Yeah, the absolute value squared of the amplitude is kind of the probability with which this particular base state is a solution, contains a solution of the algorithm. Yeah, so that means that if we want to run it on supercomputers, we need huge amounts of processors. Yeah, and actually of internal memory, as I write down here. Yeah, and so I'm simply listing here the zettabyte, which is 1,000, not 2, but 1,000 to the power 7. Yeah, so that is an incredibly big number again. yeah, that I cannot even pronounce. Yeah, so that's why just for reference purposes, 8 bits gives us 1 byte. The big B is the byte. Yeah, and so the K stands for 1,000 of those bytes. Yeah, and then if you multiply that by 1,000, so that basically means it's about 1 million byte. Yeah, which is 1 kilobyte. Yeah, yeah, that is the size of this number, and then it's to the power 2 up to the power 7. Then we have zettabytes. Yeah, you can do the calculations in an Excel sheet, and you will see that even Excel is capable of representing the numbers, but how to represent that in a visual way is very difficult. Yeah. Anyway, this is what I think is an extremely powerful tool for any scientific research initiative that universities may take, including UP. Yeah, and that means not only in computer science but in any field basically. Yeah, so as long as we have access to these kinds of machines, yes, people can start working on it. Yeah, these are the numbers that I took from the Excel sheet. So you see, this is, I don't even know how to pronounce this big number. Yeah, it's 10 to the power 9 is a billion. Yeah, and 10 to the power 15, 16. That is where we are now. This is actually 2 to the power 98. Yeah, that is the biggest number. Yeah, that means we are combining 98 qubits in a full stack mode, in the superposition mode. Yeah, so this is the amount of memory that we need to represent the base states of those 98 superposed, yeah, or superposition kind of qubits. So just imagine how big it is. Yeah, and so going to 98 is not a simple thing, because yes, we do need access to very powerful supercomputers with huge amounts of memory. This is a different way. Yeah, again, this is the scientific notation, yeah, which is much more compact. And you do see here is the ground state 2 and the ground state 10. Yeah, that is what I write down here. Yeah, and of course there is clearly a difference because these are exponential curves. Yeah, this is a logarithmic scale. This one is a logarithmic scale. That's why it looks like it's a straight line. It's a linear line. Yeah, but of course it's an exponential curve. Yeah, and so it stays very flat, and then suddenly it goes through the roof, basically, whether it's in the ground state 2 or ground state 10. Yeah, that is important to realize. I'm now almost at the 30th minute. Yeah, this is a big difference where we are now. The kind of research that I'm pushing forward is to be in this box. Yeah, and I don't think. We did a lot in fault tolerant quantum computing. That is true. Yeah. Now everybody into NISQ. Yeah. Since Preskill kind of wrote the paper, forget about surface code and these kind of things. We're wasting qubits. Yeah. But I think this is even too ambitious, and I think we should even still narrow down to smaller kind of and perfect qubits. Yeah. So this is what I'm currently working on inside QB, yeah, with a couple of people that I have there. Yeah, that is on genomics, and I will explain that in a couple of minutes. Yeah, but we also start working on quantum economics and finance. Yeah, but why not look at design of airplanes, wings, for instance, for airplanes, do manage traffic management in cities, encryption and decryption. These are all very important kind of topics. Yeah, so but you need a quantum accelerator, and this is what I basically, as a little company, we're actually offering that to universities or to organizations that want to start analyzing or studying what quantum could mean for their organization. Yeah, and I think that is important a message to remember from my presentation. Yeah, because if you make new applications, you will add more algorithms, new algorithms to what we call the quantum library, which is the almost top level of the full stack, yeah, that I showed. So that means we can also define new gates. Yeah, we can start working on a larger number of qubits because we still need a lot of superposition or full entanglement. But if it's in perfect qubits, yeah, then that's doable. Yeah, we still need a lot of memory. That is true. Yeah. And we need to find ways in which logical programming can be combined with quantum logic, and that's actually the language that we developed. OpenQL actually allows you to do that. Yeah. So talking about the compiler, this is where I'm now currently with QB. This is where the physics people are. Yeah. And you see that there is a big difference between those two. And of course, we need to go to this level. Yeah. And the physics people need to go to that level, such that maybe here we can start integrating again the physics results with the application results. Yeah. So that is very important. I mentioned here IBM. It seems like now I'm making publicity for IBM. Yeah. But IBM has recently changed their Qiskit compiler. Qiskit is kind of the platform that they offer universities and people interested, but they added to the compiler the possibility to compile for perfect qubits, simply showing how important also this particular direction is. Yeah, also up to the physical level, that we assume perfect qubits. Yeah, and this is where the real qubits are. Yeah, and we were mostly, well, we were actually always at this level. Yeah, we were trying to get the physical qubits, yeah, better. Yeah, not really perfect, but at least better. Yeah, so that is a bit how we need to interpret this particular kind of diagram. Now, I already mentioned, yeah, we can execute all of the quantum algorithms that we're working on very large and very powerful computers. So why not supercomputers? This is like a network of 5 supercomputers, yeah, connected with each other, and that is where we can execute any number of qubits, yeah, to the power maybe 98 or 100 or 150. That still needs a lot of memory. Yeah. Yeah, I will skip this one because that is the parallelization. Yeah, well, parallelization I think is one of the topics that we need to start working on. So this is an open invitation for anybody interested in parallelization. Well, look at quantum circuits. They also need to be parallelized, because it's when you run it on a classical machine, it does not have, well, yeah, you need to have an explicit kind of parallel version of a quantum circuit. In the quantum physical world, yeah, this is absolutely not true for some strange reason, and nobody can explain actually why that is, but we observe it is, but nobody understands why. There's always an implicit parallelism when you execute on the number of on qubits, physical qubits. Yeah, so the parallelism, yeah, you never write your circuit in this particular way. If we execute it on a supercomputer, yes, we need to have a fully explicit version of all of the parallel states. Yeah, just remember that. Yeah, and that immediately implies that we need a lot of memory. Yeah, 2 to the power 2 times 2 to the power n, and n is the number of qubits. Yeah, that is how much memory we need. Yeah, to represent the qubit states of such a superposition. And again, here this is for 50 qubits. Yeah, this is again a number I cannot even pronounce, yeah, in a normal way. Yeah, so this simply says these are the amplitudes, of course, that we need to represent. Yeah, again, now we're going down, of course, in all of the full stack. So this is the mic architecture. I will not go into the details of that, but you do see that tightly connected to the mic architecture is QBSim, our simulator. And of course, it will execute and send all of the instructions, the quantum operations and the qubit operations into queues. And these queues are then connected to different instances of QBSim. Yeah. And then we need to do measurement that's reading out the memory that we have, the classical memory of QBSim, and update maybe part of the symbol table, the qubit symbol table in the micro architecture, such that maybe at some point you can connect again to the classical processor. This is how any classical processor with coprocessor works. Yeah, so this is just an example. Yeah, I will go now quickly actually to an example, but I will run through that example. Is genomics. Yeah, genomics is the basis of any medical diagnosis and analysis, or biology, the analysis that people are doing these days. And that will become more and more frequent and more widespread, yeah, worldwide. Yeah, so this is simply a way in which I show a short DNA, which is consisting of those 5, and I have a reference genome. This is a very classical way of doing it. We have to see where this particular short read fits in this entire genome reference. Yeah, and you see here that here it says red, green, blue. Here is no, and there's another blue. So this is kind of the distance between the readout and the reference genome is quite good. So this is a good place where we can match, yeah, or project this short read on. Now, if we do that for a human genome, we need to know that we have more than 1 billion, let's say, CATGs. These are the reference genome components, yeah, and we have a lot of short reads. Yeah, they tend to become a bit longer. We're looking at 150 length. This is just 5 length. Yeah, we can be 150 length, and so we still have to then do the multi-millions to fill them up, to project them into the reference genome. That is the big challenge. Yeah. So this again, I will simply show here a bit what the reference, the algorithm is that we've developed already so far. Yeah, and actually we're further than this, but I'm simply respecting the time now because I have 2 more minutes. Yeah, and I will simply say that basically this is where we are. Yeah, we have 4 steps. Yeah, to come up with, let's say, the location found of the short read 01. That it's this reference genome. So all very small examples. Yeah, where we say, okay, this short read can be mapped onto that particular location. Yeah, so that is what we currently are doing, and which is in QB. Yeah, and QB, as you may know, is actually an extension, a follow-up company of another company that I created with colleagues in Delft, which was called Blue Bee. Yeah, now that was bought by the biggest company that's doing DNA research, Illumina, US based. Yeah, and so I said, now, okay, why not QB? My youngest daughter, she suggested the name. Yeah, so that is where this algorithm is going to be commercialized. Yeah, and I will not go into these details. Yeah, but we do want to make, let's say, a quantum accelerator for genomics, such that you can have DNA, a reference DNA, and then all of the genomic instructions. Yeah, and then simulate it on QBSim and get some kind of result. That's basically what we want to do. So now I'm close to ending. And so where is it that we are now? I think in worldwide, yeah. But I start to convince more and more people about that, but I'm not there yet. Yeah? I still have to give a lot of talks and illustrations of why it is important. So the physics world is basically in this layer. Yeah, they want to make real qubits with very bad error rates. Yeah, so -2. Yeah, and they need to improve them. So maybe try to get -3, -4. I will never even expect -15. Yeah, but at least they need to show improvements, and we don't really see any kind of improvements, yeah, in any kind of technology. Yeah, and that I think is important. And we know also maybe that the Gartner company, yeah, Gartner is an IT consulting company. They came up with a hype curve, and that goes like this. Yeah, so everybody, so in quantum we're somewhere here, and everybody says this is incredible, the best, blah 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 blah. That means like a lot of high level talk without any substantial thing. Yeah, and you see Google and Alibaba in China, yeah, going there, but before that really produces results, yeah, there will be like they will all reach a moment where they say, well, we're spending a lot of money on it, but we're absolutely not there. Yeah, and so that's when a lot of people, companies, and organizations will leave the field. And I think this is where universities like UP, yeah, can have a goal. I said, no, we target maybe more long term. Yeah, that's also what I'm saying, 10, 15 years. Yeah, so we don't ride this wave, but we start doing things in all kinds of faculties: chemistry, economics, medicine, biology. Yeah, so what are the quantum algorithms that we need? You can run it on classical computers too, as I just explained. Yeah, and whenever the physics people, they will improve. Absolutely, they will improve, but it takes much longer than they claim. Yeah, and that is why I think universities have a role. Yeah, to make sure that we don't destroy an entire technology because we don't get money from companies anymore. Yeah, so this is important. Okay, I had the figure. I was wondering. Yeah, so here you see indeed the quantum computing. I should have moved to this thing. Yeah, so you see that for so many fields, yeah, you see that happening, and that's why it is very important that we understand that and that goes from mobile robots, smart robots, digital twin, carbon nanotubes, virtual assistants, blockchain. Yeah, IBM, for instance, I mentioned it, has been developing an infrastructure to make virtual currency a reality. Yeah, but they wait, of course, until the maturity of the market is there, that there's legal maturity and these kind of things. So, but the technology is already there. So that means that everybody may leave now blockchain, but it keeps on surviving. Yeah, and the same will happen with the quantum computing too. And so that's why we as universities, yeah, we need to focus more, let's say, in 10, 15 years, but we still need to educate people, to give them courses. Yeah, that's what I did last year at FEUP. Yeah, give a course, and maybe we should try to find 1 or 2 or 3 more other courses. Yeah, you cannot have a full faculty only based on quantum computing. Yeah, because I would not even know what to teach. Yeah, but there are certainly many other topics that we could be teaching to the students. Yeah. So what is the main conclusion for me is that the full stack is very relevant. Well, in principle for a computer, but I don't know what that actually means for a quantum computer. Yeah, so a quantum accelerator. Yes, I've been working on FPGA, so I know what accelerators are. Yeah, and so I also know what the quantum accelerator can be. That means we have to look more and more at application level. Yeah, we have to suggest people working on the programming language, yeah, to make changes, to make new gates, yeah, or new optimizations. We need to develop microarchitectural tryouts. Yeah, how should we do it? Can we reuse a model that was used for another accelerator or not? Yeah, and run it ultimately on a simulator. That means on classical machines. Yeah, we definitely need more international collaboration. So that's why the quantum flagship as such is good, but that's a pity. It's too much dominated by physics people. Yeah, and everybody claims money and everybody claims results, but we are absolutely not there. So we do need, maybe in the flagship or in other ways, in other EU programs, other ways of getting financial contributions. Yeah. So I already said classical computers can be used for that. Yeah, and that we already showed in the Intel context. It's not that simple to do, but it's with a simple cross compilation that we can go to any kind of new target technology to execute the same algorithm. Voilà, that's 45 minutes basically that I was talking. So I'm open for any kind of question that you may have. Thank you.
Thank you, Professor Bertels. We now have some questions. I also have some questions of my own, but I'll prioritize those questions that were made in our Q&A Slido. So you have here 4 questions, 3 are for Dennis, but the first one says that you said you can't read the content of multiple qubits and therefore destroy the states of the qubits to read one. But actually, how do you read that one? It's a question from Dennis.
Yeah. Well, the readout is not done by the eye, right? Let's be very clear. We're at the subatomic level, so we're working with most likely with electrons, yeah, but it can be photons. It depends on what kind of technology you're using, and of course you need to have, let's say, a readout of the qubit memory that has been created. So that needs to be done again with some kind of what kind of magnetic or electromagnetic or whatever it is that you use for your qubits. Yeah, you need to read out the state. But again, as I said, it is already in a multidimensional universe. Yeah, because you expand. We're used to living in 3 dimensions. 4 with the time dimension of Albert Einstein. Yeah, but if we do it mathematics, we can go to 100 or maybe 500 dimensions. Yeah, and so that means you can never read out all those dimensions at the same time. Yeah, and so therefore and maybe that will be solved in 100 years, in 200 years. But for now, when we want to read out, you have to collapse it. Yeah, you basically destroy all of the layers except one. That's the one that will produce some result for you. And that's why we need to have multiple runs of the same algorithm, the same number of qubits, the same parameters. Yeah, do multiple times of measurement, and then we will have, let's say, some kind of normal curve in which we said this particular qubit state contains the correct result of your algorithm. That is that's maybe a long answer, but that is the only correct answer that I think you can give.
Yeah, thanks. We have also the question from Dennis, follow up on this. It states that what will be a solution when quantum computers can break the RSA algorithm? It's increasing the amount of bits a solution. I've discussed this earlier, but Professor can comment on this.
Yeah, so indeed, encryption and decryption is based on the RSA kind of thing, which assumes a large number of bits to represent a big number, and then you have to find what prime numbers multiplied with each other give the big number. Yeah, that is the principle of encryption. Now we know, I think it's Peter Shor that came up with an algorithm that actually shows that you can break any kind with sufficient number of qubits, you can break any kind of RSA mechanism. Yeah, so that basically means if we have a quantum computer, we can break any kind of encrypted code. That's why the encryption field, as a scientific field, they already start working on the post-quantum encryption. Yeah, because we know that is specific kind of mathematics, tensor mathematics for quantum operations. And if you go into completely different new kind of mathematics, which cannot be treated yet or implemented in a quantum way, then you're safe again. Yeah, so that is basically the main thing. It is one particular algorithm that was shown and proven to be breaking any kind of RSA encryption. Yeah, but if you go to a completely different kind of encryption technology, then you're safe again until people will break that code too.
Yeah, thanks. We also have here a question I'll read out that is from Philippe in a combination with Dennis. Philippe says that, do you think classical computing will be obsolete in 10 to 15 years? And also, Dennis, as a complement on this, how do you see quantum computing implemented in our devices? We do still need transistors to control the quantum processing unit because they seem a little bit unstable. This is two questions I combined into one.
Yeah. So the first question was, how long will quantum survive or keep on
living? Classical computer will be obsolete, perhaps.
Okay. Yeah. That's why I'm talking about quantum accelerators. That means we still have 10, 15, maybe 20, maybe 50 years. Yeah, that classical computing will continue to exist. Yeah, that all depends, for instance, on what kind of quantum technology will be used to make qubits. If it's semi or superconducting, that needs to be cooled down to millikelvin, and 0 Kelvin means absolute 0 point. Yeah, nothing moves anymore. Yeah, so we're very close to the millikelvin. That means on a single or a couple of electrons. That is so you cannot imagine a phone having liquid, helium, inside the phone to keep your qubits cold enough. Yeah, so the first 10, 20, 30 years, quantum accelerators will be on the internet, just like you have FPGAs that are being offered also, let's say, in Amazon Web Services. You can say, I want to have a supercomputer with FPGAs on top of it. Yeah, so the quantum will continue living for 10. So classical computing will maybe live for another 10, 20, 30, maybe 50 years. That's very difficult to predict. And it will always be a combination, classical with quantum and other kinds of coprocessor technologies. And what was the other question then?
It says that see quantum computers implemented in our devices. You almost reply this, say that is let's say external service we can connect and then do your computation and get the results.
Yeah.
So I think it's answered. So we'll also have another question for Marques. Do you believe that quantum computers can break or at least hack the blockchain in the future? This is something related to RSA and all the prime stuff. Perhaps it's a little bit answered concerning that. Of course, I don't know if the panelists have some questions over here. They can unmute themselves and make some questions. Perhaps not.
Okay. I want to say one thing about virtual because the quantum is not the solution for all of the problems in the world. Yeah, but virtual currencies, they may replace at some point. Yeah, given there's international support for that, they will replace national currencies. Yeah, in Europe we already did that. We have the euro. Yeah, which replaced like all of the founding members of the EU. They said, okay, we'll stop. Not the United Kingdom, but that's why they're out of the EU. Yeah, but everybody is accepting the euro, and that may still happen also for virtual currencies. Yeah, but that assumes so many changes. So it's not that quantum is a threat for virtual currencies or vice versa. Yeah, these will be very complementary kind of technologies.
Yeah. Okay. Yeah, Denise. Yeah.
Yeah, exactly. And that simply depends on how many good, really, the quotation mark, the good qubits we can make. Yeah, we need to substantially improve the current qubits. But if we reach maybe 100,000 good qubits, well, yeah, maybe 10,000 good qubits, then we can already break a lot of RSA kind of codes. Yeah, so that is still a condition. Yeah. Exactly. Yeah, exactly. Yeah.
So I have a question of my own. It's concerning the overservability problem, concerning the problem of amplification to increase the odds of the correct answer. Of course, we can repeat and repeat to get at least our most prominent answer or the visible one, while canceling the wrong ones. There is, let's say, a line of research concerning, for example, the interpretation, for example, not in quantum, but for example, on deep learning, how deep nets make their decisions. For example, if you have a computer, a quantum computer, that we throw a problem and gives us a solution, but we don't know how, because we are interested in interpretation. How do you, for example, inside quick, for example, try to interpret the results that a quantum accelerator gives us concerning our problems? For example, on deep nets, we are considering the activation maps and so on to try to realize how the problem was solved. How this can be mapped also to quantum accelerators in the same problem, for example.
It's a long question and a very difficult one. Yeah. We started. I can only say from let's say what we're currently doing ourselves is on quantum on genomics. Yeah, I had another company doing genomics, so the classical algorithms, and so you just need good enough kind of data to test your version of the algorithm. But in a quantum way, how can you predict what the quantum result will be? How good or how bad will it be? Because just imagine like it's a three-dimensional cube, or space in which you are, and you think you're going to be in the top right corner, but actually your algorithm tells you to be in the bottom left. Yeah, so that is very difficult to understand and interpret. So there is still a challenge for computer scientists, to test how and for mathematicians to test how quantum algorithms behave in a similar direction as classical algorithms. And if it's going more or less in the same direction, then that may be good enough indication that your algorithm really works. But if it's a completely wrong direction, then maybe the quantum algorithm is wrong, but maybe the classical algorithm is wrong too. And in AI, machine learning, a lot of things are produced, but nobody can really explain why this particular conclusion was reached by the computer, that in a classical way. So it's a very difficult, that's why I don't have a clear answer, because it's a very difficult problem that we don't really understand very well.
Yeah, okay, thanks. We also have a question here from the panelist Gonçalo. He states that, so as the number of intermediate variables in a function or algorithm increases, we need more instances of it to run it in parallel. Is the question if it's correct or not?
So repeat again, sorry, because
it states that, as the number of intermediate variables in a given function or algorithm increases, we need more instances of it to run it in parallel. Let's say perhaps he wants to have clones of the functions of the variables to be run in a parallel way. For example, similar to what we do in deep learning. When we instantiate the GPU, we separate the problem in several small problems to be computed on each. How this perhaps will also be done in a quantum computer, concerning the fact that if the variables need to be more instantiated.
Yeah, again, these are very relevant questions. Yeah, because we have to try to solve them. Well, to look at them also. What does that mean for genomics? If we're moving to quantum finance, yeah. Again, that is so we don't really know. What we do know, yeah, is that the number of qubits will evolve. It's kind of very fluctuating kind of number of qubits that we have from start till end. And so in the end, you may need only to read out very limited number of qubits, but it can grow extremely bad in the intermediate stages. And that is that is something that we still, that this is for us an open question. I don't have an answer to that question, because we have to look at it and study it ourselves in the genomics application that we're looking at. And we will start in a couple of weeks on quantum finance. So we'll have to do the same thing also there. So that again, good question, but I'm sorry, I have to stay very silent in answering it.
So I have a question also. It's not concerning in terms of computer science, but more in let's say cost issues. For example, we now see, for example, the evolution of several models. For example, switch transformer, basically a mixture of experts in the routing layer. And we see that the training of these models have been increasing in terms of energy cost. For example, I don't know how Google, the best one was GB3 and so on. How, for example, in terms of cost to run this kind of genre of algorithms will be in a quantum computer, for example, will be a similar, perhaps even, I am not considering the cost of the infrastructure, just the cost for running it. So how do you manage, let's say, in terms of energy efficiency? Because this is something that is being rising among the community, and I think it's relevant.
Yeah, well, we all know that in the classical computer world, yeah, we have global warming, yeah, and we definitely, all of the data centers and the use of computers and all of the devices clearly in a negative way contribute to the global warming. Yeah, so if now we're going to be using, let's say, a quantum technology, let's say semi-superconducting, or yeah, where the qubits need to be generated at very low temperature, yeah, you need the cooling, yeah. So that again imposes energy cost and financial cost of those things. You do have, let's say, photonics or the diamonds. These are at room temperature. Yeah, so there is no cooling challenge there. But again, I don't know how well. They're all bad. Let's be very clear. They're all bad. Yeah, but which technology will really evolve in a much faster way than anything else? And that is very difficult. That is very difficult to predict at this stage of quantum computing. So the problem of energy consumption will always be there. Yeah, but I do think the potential of massive parallelism in the physical, yeah, the quantum physical way is as such incredible positive effect that it's absolutely worth the effort to really invest a lot of people, money, and ideas into that direction, such that we develop machines which can solve so many problems in the world in a much faster and therefore much low energy cost and financial cost. But
Yeah.
this is a prediction in 10, 20 years. Yeah, but I'm making it now. Yeah.
Perhaps they will be useful in terms of cost benefit, for example, for solving NP hard problems.
Yeah.
Perhaps if the problem is persistence, perhaps it will be suitable to come up with the costs. So, I think I don't know if people here on Zoom have more questions. If they have, they can unmute themselves and ask the questions. I think concerning the Q&A, yeah, I think you have no more questions. I also have my questions I already asked it. So anyway,
thank you, Hugo.
Okay.
Thank you very much for inviting me. Thank you.
Thank you, Professor. See you soon. Thank you. Thank you.
So we'll thank you, Professor, to be here. So I think it's time to let it go and give us insights of this wonderful world of quantum.
Okay. Thank you very much. Thank you.
So, Professor, have a nice week.
Yeah,
so thanks.
See you soon. Thank you. Yeah. Thanks.
I think now I'll give the word to Tiago. So Tiago has the shadow, so you can continue.
Thank you, Hugo. This was really, really good. So we are a little bit behind schedule. So I will call now Nelson Bilber. Nelson, are you there?
Hello. Good afternoon.
Okay, we're gonna see about companies, right? And the point of view from companies and what they're doing, and that's gonna be interesting as well. So go ahead.
I will share. Thank you. I will share my screen. We will start by presenting our gold sponsors, Primavera Software, LTPlabs, and Wakaru. And I thank in advance by your presence here. And we hope that you can talk a little bit about your projects. So I start by João from LTPlabs. We can give your presentation. I will stop my share.
Okay, thank you. Let me start sharing my screen so you can all see that. I hope you are all seeing that. So let me start by presenting to you LTPlabs. LTP is a boutique analytical-driven management consulting company that has a proven data-driven approach that enables LTP clients to address complex challenges. And we use advanced analytics and combine with business expertise to deliver a bottom line profitability. LTP is making this month 6 years of operating. We have more than 40 consultants, 200 projects. We have done projects in more than 10 countries, and we have more than 25% annual growth. So how do we do that? We focus on solutions that can increase growth and efficiency to create a sustainable bottom line profitability, because we can either do this by increasing sales or being more efficient doing our stuff. So how do we do this? This is an important thing. We use analytics, as I previously mentioned, and we can think of analytics as a journey, and that there are 5 main steps. We have descriptive analytics. What has happened? What has happened yesterday? How many sales I had? And let's look at for reporting. We can use diagnostic analytics. Why did it happen? Why didn't I sold more yesterday? Oh, because I had a stock out. That is the diagnostic analytics. Afterwards, we can see predictive analytics. What will happen? This is the main thing that everybody is talking now, machine learning. predicting how will my customer behavior, what does my customer want to watch next. This is all done by machine learning. Then we have prescriptive analytics. What should we do? What is my next best step? And this is the realm of optimization and simulation. Let's test scenarios and see which is the best one for what is my next best move. And finally, the most challenging one, transformational analytics. How can I integrate analytics in my company, in my processes, and do all these 5 kinds of analytics behind me to make change happen, to grow my company in a more sustainable way and in a more optimized way. And which clients we partnered? We have clients on all sectors. We have clients in the service industry, retail, consumer goods, and manufacturing. And LTP, as we like to say, stands for long-term partnership, and almost all of our clients have partnered with us in more than one project. So it's a proven method for us that this approach works. And what kind of decisions we help our clients? We have 3 recent examples. We have in fast-moving consumer goods, creating a web-based app with a rolling optimization engine to optimize the supply chain and production planning. This is, as you can see there, the results, they speak from themselves. We also had an optimization engine to optimize production strategy. For example, if I receive an order, should I produce or should I have stock or inventory of this project or this product? What should I do for each one to be more efficient? And how should I what is the portfolio of products that each outlet of my clients should have to improve sales? This is all example of projects that we did. But I think one question that is on everybody's mind is, why does a boutique analytical management consulting company is here? What they are talking about? And if you think these decisions that I previously mentioned, all these decisions are data-driven, that are recurrent in time. I have to do them multiple times, and some companies have multiple users using them. So they have to all be able to use it, and they shouldn't need to be IT or analytics experts. They should be able to take advantage of analytics without having the knowledge, the technical knowledge to do that. And we are creating this product, AIR, that I'm going to present, and you can see now the logo in my background, that will be the enabler for us to do this in a quick and effective way. And what is the purpose of AIR? AIR has 2 main parts: powerful and simple analytical libraries that can fast-track the development of analytical solutions, and a customizable web app that can ensure a simple and seamless deployment on the cloud or on a scalable platform. And who will use AIR, and what are the main advantages for them? We have the LTP consultants that will be able to create a customizable process for each project. For example, if I have a client that wants to do wants to create a process that will trigger multiple runs of an optimization algorithm, I can do that. Or if an optimization algorithm reaches a certain value, so I will stop, because it is good enough, and I prefer time over over a better overall solution. And R will be able to customize the decisions that each process should have. We can leverage state-of-the-art libraries because we are creating these analytical libraries with a very deep knowledge and systematization. We can tap into pre-made approach for common solutions. Why should I do this time series forecasting every time if there is already a pre-made solution? We don't have to worry with IT infrastructure that an analytic solution always have to worry with that. And finally, we can provide a standardized user experience for our internal users. For our customers, they will be able to benefit the tailor-made approaches that LTP does. They will have a centralized repository. They can control all their runs and monitor the progress, explore dashboards to show how their processes are being used and the results they are giving, and they will be able to access it through the web or a mobile app. What sets R apart? The first part is advanced modules. These modules that will have systematized knowledge of forecasting, stock management, production planning. This will be already there, so I don't have to implement that from scratch every time. Simplicity. You don't need to know web development and the IT mumbo jumbo to do a seamless deployment. This is scalable. This will work. The scalability that I previously mentioned, and the most important part for us, because we don't deliver off-the-shelf solutions, is flexibility. I have to be able to customize the workflow, and R is a canvas to deliver faster and better solutions. Who is developing this? We have two teams. The digital team that is the responsible for creating this platform and standardize the deployment that will create this Titanic product that will have to do this and more that we already have in plan. We will create tools and frameworks for LTPers so they can use in their projects, so they will be faster to deliver solutions to our clients, and also promote the best practices that when we have time-sensitive products are always, not always, but usually are put aside. So this team is also responsible to promoting those best practices. And we have the data science team that is responsible to developing these modules that I previously mentioned, that will be able to systematize analytical best practices. And if, for example, I have a new project that explored a new area and it's promising, this team will also be responsible to, okay, let's create an approach to do this in an effective way. And finally, because this is a team that is responsible for a little bit of R&D, let's see what are the promising analytical approaches so that LTP always stays on the edge. And how do we do this for each team? In the digital team, in the previous talk, we talked a lot about AWS and the cloud. This is the major cloud provider that we use, and Kubernetes as a main orchestrator of our containers. Front end, we like to use Vue, back end, Python, and the main libraries of web development in Python. And in the data layer, let's go open source. Postgres is the main one that we use. Finally, the data science team, what are what do they use? Python is the main thing. If we need to, we use it to connect everything. And you can see here all the libraries that we use when we are talking about diagnostic analytics, as I previously mentioned, predictive analytics, what are we using, and prescriptives to do our optimization algorithms and our simulation models. That's what I had to show you today. So hope you enjoyed, and I hope to see you in the networking and icebreaking activity.
Thank you, João. Nice presentation. So don't forget to have the network session. If you want to add some questions, you can put on Slido, but we will have direct access on networking to agile the process. Okay. We have here one question, João. What kind of profiles do you look for?
We are looking for a lot of profiles. We are looking for profiles in this more engineering side to do the web development, the software engineering of this platform. We are looking for profiles to integrate our data science team, or we are looking for profiles that for people who want to enter in the business world and want to go in this more management side to integrate our consulting team. We have openings for all that profiles, for all of those profiles.
Okay, thanks. In network session, we can detail a little bit more.
Yeah, okay.
Okay, thank you, João. Next presenter will be from Primavera Software, Marta Barbosa, who will present the Portuguese company that is here more than 30 years. So Marta, you can share your screen, please.
Yes. Hi, everyone. I will speak in English because I'm seeing that you all are speaking in English, but I confess we were not expecting that. So our slides are in Portuguese.
Okay, no problem, no problem.
I ask you if you don't understand anything to the question in the end. So I will share my screen. Are you seeing that?
No, actually not. No.
Okay. And now?
Yes, yes.
Okay. So first of all, thank you for the inviting to be present and to represent the Primavera. Primavera is a company with 28 years old, and our mission is to simplify the life of other organizations through the development of business software solutions. So software products that simplify the management process of the other companies, like logistics or human resources management and other areas that we will talk here. We have 350 employees over the world. We have around 500 partners that help Primavera selling and implementing our solutions. And we have above 3 million customers at the moment. We are present in some countries, Portugal, Spain, Angola, não sei se vão perceber, mas Mozambique and Angola. We were born in Braga, in the north of Portugal, and the technologic area is based in Braga, Leiria, and Lisbon, so mainly in Portugal. Here we have some reference customers. University of Porto is one of them. And what do we do specifically? As I said, we do management software solutions in two different types of companies, small companies like startups, and medium and big companies. And we have solutions, integrated solutions that have several parts that treat different fields of the management, like, as we can see here, marketing and sales, materials management, finance and accounting, production, human resources, or other kinds of resources. And in the past 5-10 years, our focus has been the development of cloud solutions. Here we have the main technologies that we use. We are a Microsoft partner, so our stack is mainly .NET, mainly .NET Core, Angular, Azure, and we can see here also some machine learning technologies, because since we started the investments in cloud solutions, we started also the investment in intelligent features. So the products that we have already in the market, in the cloud segment, have already some interesting AI features that pretend to help the managers and the decisions to make better decisions based on prediction of the future of their companies. We have a deep investment in research and development. We have a team dedicated only to the research of new and best technologies and their application in our company and our products. We are very used to receive internships of the several grades of the scholarship, bachelor, master's, and PhD. And we like very much, and we try in all the years have some collaborations with research centers. And here we have three examples: a digital transformation collab, that is a interface lab that make that receive problems from the companies and have a very specific and specialized profiles that try to answer that problems and give the best proposals. And these collaborations have been mainly in the field of AI. Regarding the life at Primavera, here we have some images of our headquarters in Braga. Is a very, we believe, a very comfortable building that promotes the work in teams. We have all in open spaces and also some spaces to more funny and rest moments, because we believe that that balance is very important. To synthesize the life at Primavera, I can say that we have a very challenging and innovative project to offer to our employees, and specifically in that team that I talked a few minutes ago the team that is dedicated to the research of new technologies and their application in our products. We promote the continuous development of our employees, making a strong investment in training. Work hard, play harder is our ideal of culture. So in fact, we have a lot of work, but we like very much to celebrate our results, and we promote that work-life balance. And to end, only talk a little bit, I don't know what kind of profiles we have here, but talk a little bit about career. I think it's important because we like to offer to someone that to start a journey in Primavera, that if they really become compromised and linked to the company, and obviously based on evaluation of their performance, we have a very clear career path to offer to our people. We have also a strong link to the society in general. So we have some projects regarding the environment or the social problems that we have in all the places we are based. And now, and because I think the image talks better than words, I have a very short video to show you about the life at Primavera. This was a HR presentation, not a technical presentation, but in the networking that we'll have in a few moments, I invite you to ask to my colleagues from the technical area to ask all the questions you can have regarding technical issues, regarding HR issues. You can make your questions after this video. Não se ouviu o áudio? E desculpa, o que é que estava a dizer antes? Que eu pensei que estava a falar. Sim. Ok, eu já envio a seguir. Ok. Ok. Muito bem. I don't know if you have some questions.
Yes, thank you for your nice presentation. We have here one question for Tiago Costa Mendes. Do you finance PhD scholarships or finance projects that somehow finance PhD programs or PhD scholarships?
Mm-hmm. PhD scholarships, we never financial for now, but we already financed master scholarships, for example. So it's a issue that we can discuss if there is someone interested in do its PhD in a collaboration with Primavera.
Okay. On network session, we can detail more about this.
Okay.
So we can stop sharing screen, please. So our last golden sponsor is Wakaru, and we have here Pedro Cabrita. please, can you share your screen? No?
It's not Pedro.
Paulo,
It's the other one.
sorry,
It's the other
Paulo.
one. It's the other one. Sorry.
Okay, no problem. Can you share screen, please?
Just a moment. Okay. Can you see my screen?
Yes, yes.
Okay. First of all, thank you for being here. I'm going to talk a little bit about Wakaru. We don't have 30 years like Primavera, but we hope to get there. We have 8 years, so we are still a young company. We are an IT company focused on the big data and the complex events with real-time and batch processing. And we also do tailor-made systems. And like I can show you here, we have also a strong connection with the SAP universe. Oh, sorry. So Wakaru has an innovation and research development area, which is recognized by the National Innovation Agency, and using all those buzzwords that you can see here, the Internet of Things, the big data, and so on. We design and build systems that are able to extract insights from continuous, but not also continuous flows of data that allow us to detect alarms and events. So we believe in the digital transformation process. Sorry. Here we can see some of our products. We have the customer smart service, which is a unified front end for commercial SAP system, which is used in the utility sectors. The utility sectors are mainly the water company and the electricity company. We have also this system, which is our main product in the R&D, the WaterWise system that I will talk about a little bit further. SAP, we have it's also a strong area of our company. We have a lot of consulting people which are certified, and we work, our specialty is in the utility area. Here we can see all the areas that we apply for our R&D unit. We main at the smart grid solution, not also in the energy, but also in the water. That's why I talked about the WaterWise system using the Internet of Things. We are engaged in the digital transformation, digital supply chain, automation, and so on. We also work at the IT services management, on-premises and on the cloud. We also do talent outsourcing. And like I said earlier, we are in the digital, we work with close with the utilities to manage the transformation process, building vertical solutions that integrates all the system that they have, namely this one here, the SCADA, which is a big system used in the utilities. The WISE solution, it's the base to build other products that we have. The WaterWise solution was built on top of the of this WISE platform, and we believe that the WISE solution, that the WISE solution is a perfect match, a good fit for the smart city and all the areas of the smart city, like the smart economy, the smart governance, smart people, smart mobility, and so on. Here we have a general architecture of our WISE platform. As we can see, we have here several layers. So we have the layers of the data. So all the gathering of the data is taken care of here. The repository of the data, the data lakes, and so on are treated also here. And we have all the analytics, the analytical operation on top of that. We use mainly open source technology, namely from the Apache Foundation, but we are also a Microsoft partner. But to do that, we use the open source software. Here, it's a wrap up that I said during this presentation. The WaterWise system. Here we can see some print screens of our product. We use, like I said, open source technology to implement that. In 2018, we won an international H2O challenge with this solution. We were of the three winners, we were the unique from Europe to win this solution. So for us, it was a great thing, and it showed us that we are in the right way. We also participated in a conference last year, the Centuries conference, that resulted in an article that was published in this conference, and I invite everyone to take a look. Here we have our certifications of the company. We have also our customers and partners who work with us in order to build great solutions for the clients. And here you have some emails, some contacts of the responsibles of the company. Feel free to send an email, and also at the networking slot, we'll be happy to answer all the questions that you have. Thank you.
Thank you, Paul. We are a little bit short on time, but
yes, I know.
on networking session we can address more technical questions.
Okay.
Thank you again.
Okay. Thank you.
You can stop sharing screen. So I would like once again thanks to all golden sponsors, Primavera, LTPlabs, and Wakaru, a virtual grabbing. So it's what we can in these situations. So I will pass the word to my colleague Tiago. We'll talk about silver sponsors.
Yes, thank you, Nelson, for your good presentation. I will briefly describe our silver sponsors on this edition of DSC 21. The first sponsor is DAB, which stands for Digital Absolute Business. Their mission is to simplify organizations' life and increase the creation of value. They provide services in areas such as electronics, hardware, programming, networks, telecommunications, and data centers. The second sponsor, the silver sponsor, is Setel, which is a power solution specialty provider. For example, they manage pre-sales, projects, commercialization, installation, and predictive maintenance on power solution systems. Third is Ripley, which works with entities to organize impactful events for a technical audience. An example of these are hackathons. I suggest you guys to look at their current competition, the World Data League. And at last, I will introduce Natixis. Natixis is a French financial services firm specialized in asset and wealth management, corporate and investment banking, insurance, and payments. They have their technology center in Porto, and they operate from there. If any of these descriptions and fields resonated with you, I invite you to find the sponsors and contact with them and their representatives in the networking events that are occurring after these presentations, and feel free to ask them any questions, especially in the Wonder.me platform after we finish the ice-breaking session. At last, a big thank you for all the companies that made this conference possible by sponsoring us. Now, I will pass the word back to Nelson to address our institutional sponsors.
Thank you, Tiago. I also would like to thank Last Ticket to help us on the process of registration on this doctoral symposium. And also our institutional sponsors, Faculty of University of Porto, Informatics, Department of Informatics Engineering, and ProDay, to help us to have this experience of organizing and also assist a conference that will be very important to us in future as future researchers. Thank you. So a virtual thanks to all. Okay. I will pass the word to Tiago Costa.
Yeah, thank you, Nelson. And thank you all the sponsors for the support. If it weren't for you, we wouldn't be here with this quality of conference. So next we will see another video from the research labs surrounding the Faculty of Engineering. And then we will go into a 10-minute break, more or less. So let me look at the watch show at 4 and 5. We will be back, and this will be for the first networking activity. So everybody should be here on Zoom. We already published a link where you can see in which team you are part of for that activity. So we will see you guys for the networking in 10 minutes. And for this, all the people that is watching us through the streaming channel, you can come back to the conference for the closing session at 6:30 in the afternoon. I hope to see you all there to count with your presence. Okay, thank you. See you.
Welcome to the Sound and Music Computing Lab at the Department of Informatics Engineering of the Faculty of Engineering of the University of Porto. Our mission is to develop technology and content for users of all levels of expertise to engage in creative musical tasks. We aim at devising novel means for interacting with sound and musical content that sit at the intersection of sound and music description and interaction. Research and projects at our lab cover topics such as audiovisual information retrieval, including audio signal processing, computational musicology, and machine learning applied to audiovisual manifestations. Within the field of interactive music system, we cover research areas like sound design for non-linear media, immersive sound environments, new interfaces for musical expression, and 3D spatial sound. Our success lies in our ability to gather senior and postdoc researchers with junior researchers and students in a creative atmosphere. And this is what defines us, a place at the threshold of scientific and artistic innovation, fueled by its people, driven by creativity. Welcome to the Computing Systems Lab at the Department of Informatics Engineering of the Faculty of Engineering of the University of Porto. We focus our work on the fields of computer systems, including advanced computer architectures, embedded and cyber-physical systems, and software notations and tools. Research and projects at our lab cover topics such as compilers and domain-specific languages, reconfigurable computing and non-conventional computing, performance engineering for high-performance computing, embedded and mobile computing, and distributed computing. Our success lies in our ability to gather senior and postdoc researchers with junior researchers and students in a creative atmosphere. Our mission is to perform applied and fundamental cutting-edge research to achieve consistent scientific advances, contribute to the education and training of human resources, establish cooperation with industry, and provide solutions for problems with societal impact. Here, one finds state-of-the-art tools and compiler techniques, FPGA and GPU-based heterogeneous computing, hardware that adapts on the fly, but mostly a constant look to the future of computing. And this is what defines us, a lab driven and inspired by custom computing and methods for accelerating changes, achievements, and innovation.
So good afternoon, everyone. We are now closing our Doctoral Symposium. We're gonna now make, let's say, a closing ceremony. We have present our panelists, Professor Augusto Souza, also José Araújo, the President of Association of Students of Faculty of Engineering. And I also try to promote some kind of discussion, perhaps of the panelists concerning several issues. So if you can, for example, have João, for example, have some kind of insights you want to talk about now. Sorry, José.
Is it my turn already? Sorry, I'm...
No, okay. I'm just, let's say, I have, of course, I'm going to give a focus a little bit different on this conference. I think it's important, considering the fact that Professor Augusto and Carlos and so on are present here, to discuss at least the current situation in terms of pandemic and the learnings. What are your visions, or at least since you have many at least more contact to students than me and perhaps other persons. What were the most challenges or difficulties they faced? What are your suggestions concerning, for example, the future learning of University of Porto, in particular Faculty of Engineering? Do you have any insights on this? I have an opinion, but I will express it later. So
okay. I'm sorry, I didn't understand at first.
So we have the president of Association of Students. I think it's important.
Of course. Well, first of all, it's needed to say that no one was expecting this terrible pandemic to happen, right? So we were caught a little bit off guard. We weren't prepared for this. I think that learning situations were already present in some institutions, but not much on our University of Porto. But we had to do it. We had to deal with it, and it went not great, I would say, at first, but we managed to be better, to evolve, and if there is something good that this pandemic brought to us, it's the fact that we showed the capacity to evolve and to adapt to this new situation, and brought us some new tools that we are now using and that are proven to be much more efficient in some cases. In some other cases, the difficulties couldn't be so easily surpassed. So, but I would say that in the majority of the cases, it was a success. So it was somehow good in the middle of this terrible situation, I would say.
Yeah, some learning curve that people need to adapt fast. Of course, not all things went perfect, but anyway, we are here to solve. I have an opinion on this. I think it's more relevant, even on the other studies, to involve students, even in the teaching process. I think nowadays in this kind of platforms is important, instead of perhaps pursuing not so fashion one-way communication, for example, showing slides on Zoom and then waiting for answers. I think people are autonomous. I think they have access to computers, at least we are here, and they can, for example, have some video or so, or even prepare the classes and then discuss it with colleagues. I think it's the way to go. At least, of course, not all the curriculum units it's suitable to do this, of course, but perhaps emphasizing that this can be done. Of course, this has a shared responsibility among professors and students and so on. But I think in the higher, let's say, finishing masters and so even higher degrees, I think this is the way to go. But I don't know, professors maybe have some opinion on this. I don't know. Professor is muted, so.
Sorry, this is a little out of the scope, but I can also say some things about this. Later on, we will make our, also José Araújo, perhaps, our finishing speech, closing the session. About this subject in particular, I myself made a imitation of presential classes. I have only theory classes, and I am using Zoom, and I'm using my screen that is tactile, and with a pen I can write exactly the same way as I do in the whiteboard. I use slides, but in a presential class, several of you have been my students also in the master degree, and you know that I need really a whiteboard to put much more things, much more material in the scope of the course, in the program. So it was not very difficult to me to do this. More difficult is to adapt for the evaluation of the students. Okay, last year I had to change the evaluation in two courses because it was not possible to make presential evaluations, final exams, not final, partial exams, what we call the mini tests, and I had to change that. I improve the practical works, the projects, and This is also one thing that usually I include in my courses as a practical side of the program, developing software, developing things. Many of you must remember the classes of laboratory of computer graphics and so, it is done. Practical classes are more difficult, okay? In informatics area, in our area, it is even more or less easy to change to at a distance teaching because we can maintain contact with students using tools like Zoom, Discord, whatever, and we can maintain some contact. We can guide the students, we can see their job, etc. In other areas, it is much more difficult. My colleagues that teach mathematics, for example, that need to see what students are writing in that paper. They put the problem and the students are solving the problem. And in usual conditions, in presential classes, the professor is around the class, around the room, seeing what students are writing and correcting them. This is not correct, go through that way, okay? Or confirming what they are doing. In teaching at a distance, it's much more difficult. Obviously, and let me say like this, let me say one thing that is very important. What we are doing is not a true teaching at a distance, okay? We are practicing something that is an urgency, and it is an adaptation of what we actually used to do in presential classes. There are schools, in Portugal we have the Open University, there are schools that teach all the subjects at a distance, but they have other strategies, okay? Other strategies to teach, other strategies to evaluate the students. But this must be prepared from the very beginning for a teaching that is actually to be done at a distance. We don't have the accreditation for our programs to be taught at a distance. Our accreditation is to taught presentially. So we have to make some adaptations, but using the same type of teaching that we use in presential classes. Let me say one thing. 1 year ago, more than 1 year ago now, when I first heard that we should move to a distance teaching model, I got afraid. As you know, I have the responsibility of the Pedagogical Council of FEUP, and I was very afraid. I imagine that many colleagues of mine would not be able to accompany this movement. Completely false. We can, obviously, we have always some exceptions, okay? 1, 2, 3 cases, but the most of the crowd of professors in FEUP made a great effort to change their way to teach at a distance mode, in a distance model, okay? Sorry.
Okay, thank you, Professor. This is also a brief.
Could I just?
Gonçalves, yes.
Yeah, could I just add one more? Just share with you all an idea. I think obviously we're still facing this pandemic, but I think that regarding teaching, I think that when we are through this pandemic, there are a lot of lessons that we can learn from this time. And I think that during these times, this just to share with everyone, this was my first year as a teacher. I always joke with my students saying, what a great year to start being a teacher with the pandemic. And it brought a lot of challenges. And having to innovate the way we teach created new dynamics that I think that we can adapt and that we can use even after this pandemic finishes. I can just give one small example. What I do with my students in my class, in the first classes, I shared my screen and I programmed with them. Sometimes I intentionally made some mistakes. Sometimes accidentally, I'm genuinely made mistakes, and that was always an opportunity to discuss some ideas. And this semester, what I'm doing is I'm asking students to share their screen and actually be them the ones programming. And that way, I choose the students who I think interact the less, and that's also a way of solving of at least mitigating the problem that Professor Augusto mentioned, that it's hard to control what everyone is doing. So just this idea that we can learn a lot from these times.
Okay, just this was just a brief, let's say, outside, just to take in consideration some concerns of the association students president. So we now have, let's say, our best paper. I have arranged, let's say, consider the statistics and so on. And I'll tell Philippa who he is, so she can. It's in the chat. Sorry, Philippa.
Okay, so hello everyone. I think that I just want to say a quick thing before we get to just to create a little more suspense before we get to the best paper award. I just want to say thank you to everyone, to all of us actually, that we made this possible. I think we did quite a lot of big things, and I feel happy for us, and I think all of us should feel the same way. I think it went really well, and let's see what the future holds for us. So now, after the suspense, finally, I can say that the person who won the best paper was Gonçalo Leon with his paper about spin picking. So Gonçalo, congratulations. Okay, if you want to say a few words, but let's not go into
Thank you.
a long speech.
No, just a quick thank you. I would just like to take this opportunity to thank the people who I have shared my journey in this. This paper is related to my master thesis and now my PhD thesis, and I just would like to thank my supervisor, Professor Armando Souza, and my co-supervisor, Professor Germano Veiga, and also Carlos Costa, who is a great friend and a great mentor to me.
Okay, Gonçalves, just to add a little thing, a detail that as prize for the best paper, it is planned to have a symbolic gift of a total value of 100 euros. That value is reserved in the conference budget, so we'll have to talk about what that is going to be transformed in. Okay, congratulations.
Okay, thank you.
No West Orleans in beer, right?
No.
So I think in terms of our symposium, concerning the circumstances, went pretty well. I need to thank many people here that, let's say, helped us mostly and more directly to this platform and many other platforms concerning Dinis and José Borges. They were, let's say, very active on this. They provided almost solutions without, let's say, almost their own. We also want to thank all our sponsors. This is important because there are people here in this symposium and perhaps other people that are from many different fields of, for example, I'm from data science, machine learning, other people are for informatics more pure and so on. And I think it's important to companies to have a close relation what is being done at the University of Porto. Because sometimes we are doing things, or most people have a lot of skills in particular areas that those companies might be interested, and sometimes they don't explore it. Sometimes it's a window of opportunity that is lost. Of course, we PhD students have some kind of very narrow, let's say, focus on what we want to do. But of course, sometimes we have master students and many others, and also contributions to new projects and perhaps opening the window of new contributions, and even, for example, supporting perhaps a master student that has a close connection to a company, I think is the way to go in terms of informatics, computer science, and to narrow the connection between the two groups. That I think in Portugal is very, very far away in some areas. But of course, that's why we try to promote this kind of, let's say, forum to reduce this gap. So in terms of our symposium, I also want to thank all the track chairs for their efforts, Gonçalves and so on. Also to my partners in terms of the committees, Filipe, also the steering committee, Professor Augusto and Professor Carlos, and of course all the two members, Soraya, I don't think she's here, yes, and Tiago Mendes, for all the commitment they put in this forum, and I know that it was not small. There are a lot of sacrifices for everyone, even considering the fact that it's a little bit late and it's starting to have a collision with other semesters. But I think at the end, the result was very good. Some lessons were interesting, and we can bring it home, also me. And from my part, I have learned a lot, and new interested people I met. So anyone can talk on this, Tiago and so on. Filipe.
Yeah, thank you, Hugo. I think we can pass to the final speeches. What do you think? And maybe the Students Association president first.
Yeah, we can now, let's say, resume our normal agenda in terms of what was, let's say, the formal issue.
Yes.
So perhaps we'll start with, I don't know, what was perhaps José, right?
Yeah, yes.
José,
Okay.
now you can be more formal in terms of the speech.
Okay. Well, in first place, since I've just started, maybe I will start by congratulating Gonçalves Leão for the best paper. Congrats, Gonçalves. I'm very much pleased to be here today on this closing ceremony. It is a great honor for us to be invited to the symposium and to contribute. So we will always be here for you and to help by any means that we can. Informatics is not actually my field of expertise. I'm actually from chemical engineering. I'm almost graduating. I'm finishing my master's thesis dissertation this semester. So, but I'm actually an informatics enthusiast. I'm learning Python programming right now, and I really think that programming is a very powerful tool for every engineer, despite the field of expertise. So I am really sure that I will be using a lot of programming in my future. So I'm really pleased to be here with you today. I hope that the event was a great success. I don't hope, actually, I know that it was. So congratulations to everyone involved. Congratulations to the organization team and to everybody here. Thank you.
All right, thank you, José. And now, Professor Augusto Souza, can you please take
So
the
it is
stage
my
and the
turn.
mic? Yes.
It's my turn now.
Yes, please.
Okay, guys, let me start with the formal compliments first for our president of the Students Association, José Araújo. It's a pleasure to see you here. We have been talking about this also in the past. It's my pleasure to see that the Students Association is also near the students of PhD, okay? And the contrary also. This approximation is very welcome. Usually the students of PhD are, let's say, a little different from the others, have a different life inside FEUP. No, they are students and they have Students Association that also represents this type of students. José Araújo, thank you very much for being here, supporting this connection, and also to my thanks to organization for inviting José Araújo for this ceremony. My compliments also for the director of ProDay, Professor Carlos Soares, and my colleague teaching this course. And a special word is due to the sponsors, to the industry that is here represented. And I usually say that a school of engineering prepares students to go to the industry. So this approximation between industry and the academy in a school of engineering is a natural thing. And we in the executive board of FEUP have been a great effort to improve this approximation. Thank you very much for participating. Thank you very much for being here in this event also. Obviously, a special compliment to all the students of ProDay, to other students in general, to all the participants of this event. This was the Doctoral Symposium on Informatics Engineering, and it was the 16th edition. I'm not mistaken, am I? 16th, okay? Yeah. We started in 2005. This event, in my opinion, is an important learning tool. It's like a laboratory. Yes, it is included in the core scientific research methodologies, and it is a real test bed for the knowledge that is previously acquired in the first part of the course. It helps the students to answer some questions. What is that of writing a scientific paper? Some of you already know, some of you already did it, some of you never did it, okay? Even those that already did it, it's not wrong to listen to acquire some information about what is expected from a scientific paper. What is the proper structure of a scientific paper? How should it be presented orally in a conference? How is a paper reviewed by peers? Very important also. How should I write the paper facing the reviewer or taking in consideration that it will be reviewed by another person? If I know how that person or that reviewer thinks, perhaps I can improve also the quality of my paper. What are the proper methodologies to be used in the scientific work and in writing the paper? How to answer questions about the work, the questions that you had to answer at the end of your presentations. And even more, learn about a conference itself. What is a conference? Okay, definition of topics, the scientific issues, the scientific duties also, but also some bureaucratic issues, some financial problems, some problems. Yes, organizing a thing like this has many problems to be solved, and you did it. We were presented actually with very good presentations during this event. Presentations good in structure, good structure facing those parts that we believe must be part of a scientific presentation, good slides, good presence of the presenters, good posture, okay? Some presentations have presented a good scientific content, others still not, okay? But in overall, I think this was an excellent seed for your PhD works. Naturally, some cases need some improvements, obviously. For example, the state of the art was missing, the results or discussion was not complete, the conclusions were not well formulated. Some of you need to improve the English language. Some of you need to improve the assertiveness to present one paper. Obviously, you are starting. You are just starting this job. Now that the symposium is finished, you are, I believe, much more prepared, because you have to pass the experience yourselves, and you saw your colleagues. You heard the comments to yourself and the comments that were made also to your colleagues about your presentations, okay? In the next 3 years, next 2-3 years, you will publish many papers. You will participate in many conferences. This is usual. This is what is expected to be, okay? With this, that you learned here in this symposium, you are now, I deeply believe that you are much better prepared to follow your job in the next years. Permit me an advice. In real conferences, audience will not be friendly as this was, okay? In real conference, all the audience will be searching for a small mistake of yours, okay? So we here had a controlled event, a closed event and controlled. All of us are friends of the others, okay? But it's a friend, a critic friend, okay? I believe a friendly environment that must be used for training, okay? And this training has their objectives, has some results that I hope are good. Yes, I'm sure that this experience will be very useful for you from now on, okay? So for you as organizers, I remember that the first moments, the first talks that we had about this were somewhere in the last October, several months ago. And we had some classes trying to describe what is a conference from the point of view of the organization, from the point of view of the scientific side, etc. A long way was made since then. A long way made in adverse conditions, and I must reinforce this, in adverse conditions. And this event was your work, was due to your work, your organization. Several of you, not saying all, but several of you have worked a lot to make this, worked autonomously. Me and Professor Carsoar were already there for what was needed, but you worked alone, autonomously, as I was saying. The work was yours. Pressure, I know how things are. Pressure increased a lot in the last days, last weeks, in the last days. Yes, it's usual, it's normal. And pressure, sometimes it's good, okay? But let me say that I must confess that you made an excellent job. Excellent in caps, okay? Excellent job. Results are, we could see them, excellent. Perhaps I would say one of the best events that we had during all these years, okay? in spite of the difficulties, pandemic in first place and others. The class was big and it was necessary to give work to everybody. So we subdivided the conference in tracks to be sure that everyone has some work to do. And I believe that more or less it worked well. It is a pleasure to see now as a conclusions that our students in general, not only in Pro Day, not only in this symposium, but in general, I used to say our students don't give up. They continue hard and harder with their activities, even with big difficulties as this pandemic has been until now. So let me make a kind of small summary. You were the organizers of the event. You were the authors of the papers. You were the reviewers, not but part of the reviewers of the papers. You were the presenters. You were the participants. You made all the job, or you made all the event work. Along all these years, and at this precise moment of this talk, I ask you all one more thing. And this year it is very, very well deserved. I ask you more than ever, I ask you from you all to you all a big and loud applause because the work was very well done. From you all to you all. Yeah.
Thank you.
Well done. Please, as a conclusion, accept my congratulations as a professor. I believe that my opinion is shared by Carlos Soares. Believe me that my opinion is also shared by our director, Professor João Falcão Cunha, that is not here but was in opening session. And one special remark that I am very proud to be able to say. From the starter of these activities, Professor Eugênio Oliveira, he cannot be here in this ceremony, okay? He was during the event, but by other reasons, by other professional reasons, he cannot be here at this precise moment. But he asked me to transmit you that he is very happy, very, very happy with the quality of the things that he saw during the event. So to you, his congratulations also for your work, okay? Professor Eugênio Oliveira. To finish, next days is our work, me and Professor Carlos Soares, okay? We have to collect many notes, his notes, my notes, notes from the reviews, notes from whatever, okay? And later, we will produce your grades. It will not happen tomorrow, not after tomorrow. We need time, okay? We need time to collect all this information.
No problem.
Paper writings, remember, your grades depend on the paper writing, your oral presentation, the quality of the reviewing texts, the involvement in the organization, the active participation in classes, the active participation in the conference. All this will be influencing your final grade in this research methodologies course, okay? Please be patient. We need some time to do it. And guys, I'm very happy with the results. Thank you very much.
Okay, thank you. I don't know if Professor Carlos Soares wants to speak, or should we finish here? All right, so.
No, I just want to say congratulations.
Okay, thank you, thank you. So it's time to say goodbye to our watchers on YouTube. So I thank you all for your attention. I hope the conference was good for you. It was enjoyable. Just stay safe, there will be another conference like this, or maybe better, next year. So have a nice rest of the day.
Hopefully not organized by us.
Others will come.
Yeah.
Every day, researchers try to solve real problems through real science. Here, we do the same. We just take it with a pinch of humor and a creative mindset. Welcome to GIG, the Computer Graphics, Interaction and Games Lab at the Faculty of Engineering of the University of Porto. GIG is a place where science meets imagination and innovation is an attitude. Our mission is to research, explore and develop the fields of computer graphics, interaction and game design and development through the continuous evolution of the connection between people and systems. And we do so in a highly transparent, efficient, natural and pleasant manner. GIG is all about its people and what they can achieve together. We gather senior and postdoc researchers with PhD and master students and other junior researchers in a collaborative atmosphere that leads to top-notch research projects. Research at GIG in computer graphics revolves around 3D modeling and animation, realistic and real-time rendering, as well as procedural modeling of 2D and 3D environments. These core topics are explored at higher levels in contexts such as multi-sensory virtual and augmented reality or games. In the field of human-computer interaction, we focus on user interaction and user experience, applied not only to regular computer applications, but in particular to immersive or mobile environments. We combine technology and design principles to research and develop multimodal, natural user interfaces and study their usability. Graphics and interaction come to play together with other topics in the multidisciplinary field of game design and development. Here, we work not only in the processes of game creation, design, and development, but have a particular focus on serious games, location-based games, and gamification. At GIG, we believe that excellence in these main fields of research is only achievable through creative collaboration. To uphold this multidisciplinary approach, we work together with other key players at our faculty, such as the Sound and Music Computing Research and Development Lab or the Computer Graphics and Multimedia Students Group. We go beyond the Faculty of Engineering, having frequent collaborations with research groups at the faculties of Fine Arts, Psychology, Sciences, Liberal Arts, and Economics. This is what defines us, a passion for enabling engaging experiences through multidisciplinary research, from people to people.